Hey, Nathan here. Welcome to a new series covering the PGL2D Alpha release. And in this series, you're going to learn how to create a alpha build of a game library that you could use across different projects. Now, this is the alpha build. Things that we have created in this series will be modified in the beta and final build of the library. Things that we have not built will be built in the beta and final release, and things that look good now will possibly change in the beta and final release. So what you see here might not reflect those classes, or interfaces might not even exist later on down the road. So this series will be 28 parts. 28 tutorials. This one is an introduction, it's not a tutorial. And at the very end of the series, I do a looking back video. It kind of does the opposite of this video. This video is looking forward. I just call this an introduction series. And the very last video of this series will not be a tutorial. It'll be labeled as a tutorial just for numbering purposes, but it will just be a looking back on my thoughts of the whole series and what I feel of how it works, and look at it in a programming view and look at it in a content producer view. So look forward to that at the very end of the series. So 28 videos. Each one of the videos dedicates itself to that specific class or interface. And this series, since I haven't released any videos in a while, I decided long ago that this series was going to be, each tutorial of the series was going to be uploaded every single day. If you go to the PH Studios website and look at the calendar, I've already updated the calendar for the actual tutorials that you see. And that pushes it to the actual deadline of the giveaway. So it'll run all through June, and the last Sunday of June, the series will end. Now that will be the tutorial. 1 week after will be the looking back. So if I look at this one, that's looking back. That's 1 week after. And now I'm back to releasing videos every week. Now that'll be the flat paddles, but if you look at how it looks, that pushes it to the end of September. So I'm probably going to make some adjustments. The PGL2D series on the calendar, that's set in stone. You can follow that directly. That will not change. The flat paddles, I might change that to make it more frequent so it doesn't push it to the end of September. And in between that, I will also release other tutorials as well, so don't assume that that's the only tutorial you'll get for a weekly basis. There will also be game algorithms or game mathematics videos, or just random stuff, random C# videos and stuff like that thrown into this mix as well. But this will give you the idea that without any modifications, up until the end of September, there will be consistent. 1 week we'll have a tutorial. That's assuming I do not change any of this. If I do change any of this, it'll be more frequent. 2 tutorials this week, 1 tutorial this week, 3 tutorials this week, a tutorial on a Tuesday or a Wednesday or Thursday or anything else. But there will always, up until the end of September, at this moment, you'll have a tutorial every Sunday. Let me take a drink of water quick. And then while this is going, I'll be working on more videos. So I have a giant backlog of videos. I'll have until the end of September, without any modifications to this schedule, I have until the end of September to create more videos. That's a lot of time. So there will be a massive backlog of content going forward. It would have been even more if I decided to make the PGL2D 1 week as well. But since it's been a while since I've released any videos, I have decided long ago that this is going to be uploaded once a day. Now, this is in Eastern time. I believe if you add this to your calendar and your time zone is different, it should automatically adjust. So keep that in mind. And the time does not really matter. That's pretty much my deadline. If I get home from work and want to upload the video on Tuesday right away at 5 o'clock, then that video is going to be up at 5 o'clock. I'm not going to wait until 8 o'clock in case I have something going on. That's just my deadline. So the day is more important than the time. Don't expect at 8 o'clock that's when the video will be uploaded. That's pretty much my deadline. I need to get it up before 8 o'clock. 8 o'clock at the very latest. And that's my schedule. So every day there will be a new PGL2D alpha video up until the end of June, or the last Sunday of June, which is also the last day of the Final Fantasy X and 10-2 giveaway. And then after that, everything will go back to a weekly basis. Okay. So this video, again, is going to be 28 tutorials. This is tutorial 0 for introduction, and there will be a tutorial 29 for looking back, but those two are not really tutorials. They're just marked that way for numbering. 0 is an introduction to the series, and then tutorial 1 is actually where we get started, all the way to 28, yada yada yada, and then tutorial 29, that's the last one for the playlist and last one for the series, so it's going to be labeled as such. And that just looks back on my overall thoughts on what my thoughts are for the series. Okay, I've also, if I go back here and go to the source code, I've also split up all the source code. Let me make sure that all fits. Okay, yes. So tutorial 1 structure, I'll release all these. These will all be the project files. Every tutorial will have its own zip that you can download and view the result. Alright, so stay tuned for the actual first tutorial, which will be tomorrow by 8 o'clock. Monday the 30th by 8 o'clock. So, I hope you enjoyed the series. This is the first series that I've done in bulk. Everything's recorded, as you can see here in this file folder. Everything is already recorded. As of now is the, I can't really show you the time, but it is Sunday the 29th, May 29th. And I'm recording this the day of. This is Sunday, and this series starts. So everything else is done except for the looking back, which I can do as this is going on. And that's just me sitting and talking, so that's not a big deal. But everything else, all the actual content is already recorded. You can see here, all the video files are done and ready to be uploaded. All the source code is done and ready to be uploaded. And hopefully you enjoy this series. There were a few things that I had to do hard cuts on, but overall, I think the series is pretty good. So stay tuned for the actual start tutorial 1, which will be tomorrow, and then stay tuned every single day, which will be a brand new video. Alright, one final thing, and then I'll cut this video. I mentioned this before, but I'll mention this again since this is the actual part of the series. What you see here, every single day there will be a video. However, if something comes up, if I don't have internet the whole day for whatever, or if I know I'm going to be out of town one day, or I will not have internet access one day, I will make up for that. On average, it'll be a tutorial a day. If I miss a day for whatever reason, internet's down or whatever, or there was a giant emergency or, whatever, I can't control there's some things that I cannot control. If I miss a day, or I know I will miss a day, I will release 2 tutorials in one day. So, for example, if I know I'm gonna miss Wednesday the 8th, I will release 2 videos. I will release the actual tutorial 8, the tutorial text entity. I will also release that on Tuesday the 7th. So if I know I'm gonna miss Wednesday the 8th, on Tuesday the 7th there will be 2 videos uploaded. And then no videos on Wednesday the 8th, and then we'll go back to normal on Thursday the 9th. So on average, it will be a tutorial a day. I just wanted to give that disclaimer, just in case something happens. For whatever reason, I don't know what's going to happen any day of this month. I can't guarantee you that, this video will be uploaded this day. If it is not, it'll be adjusted in the day before if I know ahead of time, or the day after if I didn't know ahead of time. So this can fluctuate, but on average it will be a tutorial a day. Alright, that's it for this introduction. I hope you enjoy this series. Let me know what your thoughts are. This is also the first series I've done with OBS, and I've loved it. So, hopefully you enjoy it. Thanks for listening and watching, and I'll see you for the... Hey, Nathan here. Welcome to the first tutorial for the PGL2D series. And in this video, we're going to create our project, and we're going to work on the structure. So, in your Visual Studio, go to New Project, and we're going to do a Windows class library. And call it PGL2D, or whatever you want to call your 2D game library. And click OK. So this is going to be a very quick video, just adding all the folders we need and discussing the overall structure of our library. So we can go ahead and just delete this class it generated. We don't need that. The one thing we do need to do is add a reference to monogame. So right click your references and go to add reference. And if you haven't browsed to it yet, if you have not done this yet, the path is in, if you're running 64-bit Windows, it's C, Program Files x86, Monogame v3.0, Assemblies, Windows, and then monogame.framework.dll is the one you want to use. So I'm just going to add that and click OK. So now that that is added, we can use everything that Monogame has, like Vector 2, Texture 2D, all that stuff. So now let's work on the folders a little bit. So let's right-click the project and go to Add Folder. And let's name this folder Collision. And these folders are going to separate similar classes together. Like there's multiple collision classes that are going to go in that collision folder. So let's go to Add New Folder. Game. Let's add another folder. Game Object. So we'll have a updatable game object, we'll have a freezable game object, we'll have all sorts of game objects. Let's go to Add New Folder. Input. We will have an input system, we'll have an input map, extensions on the mouse and keyboard to kind of help us work on those states a little bit better. And let's right click that and go to add another folder. Screen system. This isn't being used in the paddles tutorial, but a screen system would be used for, we have our game screen, that's where you play your game. Then we have a menu screen where you can you have several options like play game, options, view, controls, that kind of thing. And the last thing we want to do is add a utility folder. Now this folder will be used for extensions if we want to extend functionality that a class exists. For example, if we want to extend the Texture 2D class, So this is the overall structure of our initial PGL2D. This is the alpha version and what the paddles tutorial will be using. So next tutorial, we will be looking at the iCollidable. We will start looking at the game object stuff. iCollidable, iMovable, iRemovable, iHideable, and iFreezable will be the first several interfaces we're going to add. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. Last video we discussed how to structure our class library by adding these folders that you see here. And in this video we want to start creating our classes. Before we do that, we need to create several interfaces. The first thing we want to create today is the iMovable interface. So that's going to be related to game objects. So let's right click the game object folder and go to add new item. And let's select interface and let's name it iMovable. So iMovable. Alright. So this is going to be a public interface. So iMovable, that's going to be, we're going to use that to indicate when an object can move. So what do we need to know when an object moves? Well, we need to know the angle that it's moving. And we need to know the speed. We also need to combine those two, which will give us velocity. And we also need to know the acceleration. That's if you want to speed it up over time or slow it down over time. Okay, so let's add those four values here. Float, angle, get, float speed, get, vector 2, velocity, get, and vector 2 acceleration get. And be sure to add using Microsoft.xna.framework right there, and you can delete all these other using statements. Okay, so any class that we make that includes that interface, that will guarantee that those classes, those objects will have an angle, a speed, a velocity, and acceleration. And this is a public interface, so anybody that uses the PGL2D and wants to create their own, they can use the iMovable interface in their own project. And anything else that you might need, like gravity or something like that, that will actually be iPhysical, not iMovable. But anything else that you can think you might want to add for iMovable, you can add it in this interface. So that's it for this video. The next video we will discuss iRemovable. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to discuss the iRemovable interface. Last tutorial, we discussed the iMovable interface. That is what we use to indicate that an object can be moved by guaranteeing that the object will have an angle, speed, a velocity, and acceleration. An object cannot move if it doesn't have speed and an angle, which will give us velocity. And acceleration is a bonus. You might not need that. We'll definitely use that in the future. So this interface you see here, that is used to indicate to everybody that if they are using that interface, these four properties are guaranteed to be there. So let's do the same thing with iRemovable. So let's right click game object and go to add new item, and it's going to be interface, and iRemovable is the name. Removable. So iRemovable, that's going to be used to determine when an object can be removed from the game completely. If that object is off the screen or if the object hit the other player, we do not need to have that around. We can delete it from the game entirely. So bool, it's going to just have one property. Request deletion. Get. So iRemovable. That way we can loop through all iRemovable objects and delete them if they are set to true. This will be used in our game to clean up. We don't want to have 500,000 bullets all the way at the edge of our screen when we don't need them anymore. Now, if your game creates and destroys a lot of objects, we want to be careful about using that. You can store a lot of those objects in memory and just reset them and use them later. But for simple games, we can just request deletion and delete it. Alright, that's it for this video. I hope you enjoyed it. Next video, we will discuss iHideable. And once we get through all these interfaces, the tutorials will be much longer. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we're going to discuss the iHideable interface. So let's go ahead and get started. Let's right-click Game Object, and let's go to Add New Item. It's going to be an interface, and call it iHideable. So it's going to be a public interface. And iHideable, that's going to be similar to the iRemovable that we discussed in the last tutorial. iHideable is what's going to be used to determine when an object can be hidden from the display. It can still be updated. It's hidden, but it can still be updated. So for example, if you have a power-up that will grant you 100% invisibility, it'll be hideable, but it will still be updatable. The object can still move around and shoot or whatever, but it will be invisible to the screen. So let's set that bool is hidden, get, and set. So we can set it as well. We can set is hidden to true or false. So that is it for this video. Next video, we're going to discuss iFreezable, which will be the opposite. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we're going to discuss the iFreezable interface. So let's go ahead and get started. Right-click Game Object. Go to Add New Item. Let's go to Interface. And call it iFreezable. And last video, we discussed iHideable, which is it'll be invisible to the screen, but it can be updated. We're going to do the opposite of that, where it's going to be visible on the screen, but it cannot be updated. So, it's going to be a public interface iFreezable, and just like the iHideable, we'll just set bool is frozen, get, and set. Alright, that is it for this video. Next video, we're going to discuss iPhysical. I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, I'm going to discuss the iPhysical interface. So let's get started with that. Right-click your Game Object folder, and let's go to Add New Item, Interface, and call it iPhysical. And that's going to hold all physical properties of the object. Public interface, so things like color, rotation, scaling, the scale vector, and the position. Position is physical. That's where you are in physical space. Velocity and acceleration is movable. It's still related to physics, but it's a movable property. Okay, so let's get started with color. Color. And we need to add Microsoft.xNative framework at the top. So color, get float rotation, get float scale, get vector2 scale vector, get and vector2 position. Get. Alright, so that will hold our color, what our object's color is. The rotation. Now, the rotation, you can be looking one way, but moving a different way. I can be looking up, but move horizontal. So that rotation is different from angle, which is the movable property. Scale, determine how big or small our object is. Scale vector, that will determine how big or small our object is in X and Y. If it's different, we can stretch it X or horizontally or vertically. And position, which is just related to physics, just where you are currently. Which will be in relation to the top left of the screen, like right here where my mouse is, right next to the Visual Studio logo. Alright, so that is it for the iPhysical interface. Next video, we are going to discuss the game entity class. So I hope to see you next time. Hey, Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video, we're going to discuss the game entity class. So in the last few videos, we have discussed a few interfaces. And in this video, we're going to use a few of them in our class. This is going to be our root game entity class. It's going to be an abstract class. We will not be able to create an instance of this class. So let's right-click our game object folder, and let's go to add new item. And it's going to be a class this time, and it's going to be game entity. Alright, let's minimize that. It's going to be a public abstract class. Now this is going to use the three interfaces we're going to use for this is iFreezable, iHideable, and iRemovable. And you can add all those properties that we made in those interfaces, you'll have to add those in our class. If you're using a ReSharper, you can just click that little red light bulb and go to implement missing members. And then finish that. So we just needed to add iFrozen, is hidden, and request deletion. And that is complaining about, okay. The other thing we want to add is another public boolean. Public bool initialized get and private set. Our request deletion, that's going to be internal set. We only want to set that in our PGL2D library. Is frozen and is hidden are fine with public set. Now let's create the constructor. Now the only thing we're going to set in the constructor is initialized. So we're going to set that to false. It is not initialized at this moment because we're going to have a dedicated initialize method. Now the constructor will be used to populate all the properties and everything we need to construct the object. But to actually initialize the object, we're going to use the initialize method. So after all of our properties, let's create a public virtual void initialize. And that's going to just set it to initialized is equal to true. Next, we want to have a method to uninitialize, which will set it to initialized as false. So I chose the name terminate for that. Public virtual void terminate. Initialize is equal to false. So this method will handle if the object will be deleted or if the object will become in an uninitialized state. For an example, I mentioned in a previous video where if you're creating and destroying a lot of objects, you might want to keep a lot of those readily available. You'll just have to reset those. Like a particle system, for example. A lot of implementations of that use a whole bunch of particles already generated. You will just reset the state and set its color and everything depending on what the particle should be at that instant. When it's destroyed, it goes to an inactive state and it will become ready to be pulled from the pool again. So that's why you would use terminate. When you reset it, it will terminate. Everything will be uninitialized and it will become ready to be used again. This object is going to have an update method. Remember, an object doesn't have to be movable to be able to be updatable. For example, if it's non-movable, but you have a sprite sheet associated with it, it can be updated by updating that sprite sheet. Maybe it has an animation sprite sheet. So public void update. We need to provide the game time and game time. And if it is frozen, we're just going to simply return. Otherwise, we're going to call a public abstract void method. So let's go ahead and create that before we call it. Or actually, it's protected, not public. So protected abstract void update entity. Pass a game time and let's call it game time. So let's call that in our update method. So that is just going to handle if it is frozen, it's not going to do anything. Otherwise, it's going to call our update entity. Now we need to do the same thing with draw here. So let's go ahead and actually create the protected abstract void draw entity. And it's going to be game time is what we'll call it, and sprite batch. And we'll need to add using Microsoft.xna.framework.graphics at the top, sprite batch, and let's call it sprite batch. Okay, before that method, let's create a method for public void draw. And that's going to have game time, and we'll call it game time, and a sprite batch, and we'll call it sprite batch. So similarly to the update, if is hidden, we're just going to return. Otherwise, we're going to call draw entity, provide the game time, and sprite batch. So that is it for this class. It's a very short class. It's just our base for all game entities. In the next video, we will discuss iCollidable. And that will be the last interface for a little while. So, I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D series. And in this video, we are going to discuss the iCollidable interface. And this is going to be a generic interface. We're going to make it contravariant. So let's right click game object here and let's go to add new item, and it's going to be an interface, and it's going to be collidable. It's going to be a public interface, and it's going to be contravariant, so it'll be NT, and we're going to constrain it to where T is a game entity. And it's just going to have one method, bool, check collision, T entity. So that's pretty much it for this video. Now that is it for the interfaces for a while. So next video we're going to discuss physical entities, so we will be getting into more complex classes now. I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. We finally got through all the interfaces and all the very short files that we need to create. And now we're going to create the physical entity class. So let's right click a game object here and let's go to add class. That's going to be physical entity. Physical entity. And now that's going to also be an abstract class. Public abstract class physical entity. It's going to derive from game entity and physical for the interface. And if you're using ReSharper, you can just click that red light bulb and implement missing members. If you're not, you'll have to manually add the color, float, rotation, float, scale, vector 2, scale vector, and vector 2 position. You'll have to implement those properties. Okay. So the physical entity is going to hold it's part of the interface, but it's going to hold everything our entity physically needs, like the position, which we already have here, the texture, which will give us the physical representation of what our object looks like, the origin, where we want the center point to be in our object, the rectangle, the bounds of our object, and we'll have it'll be event driven. We're going to have content loaded events. So there's a few things that this class will end up doing. Let's create a private read-only string here for underscore texture name. So we're going to store this because we're going to pass that into the constructor, but we are going to load that texture when we call load content. So this is going to be a protected constructor. So protected physical entity, we're going to provide the color, vector 2 position, the string texture name, the float rotation, and the float scale. Now I set this up to only allow a single scale value, and that will set up the scale vector. Remember we discussed that when we discussed iPhysical. The scale vector will be set to the same value we had in both X and Y. If you want to extend this to have multiple scale X and scale Y, you can. I probably will for the beta release of this, but for now I'm just going to keep it a single scale value. So color is equal to color, and then rotation is equal to rotation, scale is equal to scale, scale vector is equal to new vector 2, and that's just scale and scale, position is equal to position and underscore texture name is equal to texture name. So the texture name is going to be used when we load our content. Alright, after all these properties, let's create a public event. Event handler, and this is going to be called whenever content is loaded. So if there's something that you want to do once your game object's content is loaded, just sign up to receive events from this event handler, and that will be taken care of. Okay, so the load content here, that's going to be internal virtual void. Load content will only be used internally, so we'd make that an internal accessor. Again, anything you see here, if your needs differ, you can make that public virtual void if you need it. Content manager. Content. And content manager is from Microsoft.xna.framework.content. So make sure you have that using statement. So we're going to check to see if we actually have a valid texture name. Now, what is a valid texture name? That is when the texture name value is not null or white space. So if not string that is null or white space underscore texture name. So if we have some string in our texture and it's not a white space, we can load it. We can try to load it. Texture is equal to content.load. It's going to be a texture2D and underscore texture name. And we didn't get the textures done, so let's go back up to the properties here. Public rectangle get and set. It's going to be private set. Public texture2D texture get and private set. The origin, which is a vector2, that's going to be protected. Origin get and private set. And that is it for the properties. So sorry about that, I forgot to add those. Okay, so texture content.load texture2D underscore texture name. Now we need to set the origin, and I'm going to default that to the center point of the texture. Origin is equal to new vector2 texture.width divided by 2.0f. That divides the width by 2, and texture.height divided by 2.0f, and that divides the height by 2 as well. And then once we load our texture, we can call rectangle. We can actually create a new rectangle. We provide our int for position.x. It needs to be an integer, so we cast that from a float to an integer. Int position.y, and our texture.width and our texture.height. Alright. Now we are done. We have loaded our content. Now we need to provide we need to invoke this event handler here. So I'm going to use the new C# feature null propagation. Content loaded dot invoke this object and event args.empty. I'm not going to provide any arguments. So this is null propagation, and what this does, if content loaded is null, this won't execute. If it is not null, this will execute. So this is a quick way to do, instead of having if content loaded does not equal to null, content loaded.invoke, we just do this in one line here. Okay. There's a few things that it will create. They will probably be out around the same time, if not before this. So my discussing this will be irrelevant, but I will be releasing some C# videos to discuss contravariance, what we discussed in the last video with the I collidable, what this in does, and null propagation. So I'll discuss that in more in-depth. Alright, we have a load content, now let's have an unload content. So that's going to be a public virtual void. Unload content. We're going to dispose our texture, and we're going to set our origin is equal to factor 2.0. Okay, so now we need to override our draw entity. So our draw entity is coming from our game entity abstract class here. And we're going to override it. It's a physical entity. It does have a actual physical view for the player. It's a physical entity. It exists in our game. So we need to see it. But we need to see it if texture does not equal to null. If we don't have a valid texture, we cannot display it. And sprite batch is provided to us in the call. That is guaranteed to already have begun, so we don't have to call sprite batch.begin. Sprite batch.draw. We're going to draw the texture here at position, null, origin, rotation, scale vector, color.white. I actually just provide the color here that we specify. So color here, sprite effects.none, and 0f, which these two are irrelevant. That's why ReSharper has those as a lower opacity, so it's difficult to see. So you can completely omit those if you want to. Okay, so that is the draw entity. So that is it for this class. We set up a private read-only string that holds our texture name. That gets us ready to load our content whenever this is called. Load content uses that private texture name in order to load our texture. Then we have our constructor that sets everything up. We have our properties from our interface: color, float rotation, float scale, vector2, scale vector, and vector2 position. We had to create more properties because our object is physical, so we needed these three properties as well to hold the rectangle, the texture, and the origin. We created an event handler. That way we can have things be notified whenever our content has been loaded, and we can perform more logic. We loaded our content, so if we need to manipulate that texture or we need to do something with our rectangle, we can do that after we have been sure that our content has been loaded. So we can get that set up, and we will be invoked and we'll be notified, hey, content is loaded. You can do whatever you need to do with this texture, origin, or rectangle. Unload content just disposes our texture, and our draw entity just calls our basic sprite batch.draw call that we've done multiple times before. There is one more function, one more method I want to add to the physical entity, and that's to update the rectangle. So let's scroll down to the bottom of the class and let's add a new protected void update rectangle. Var top left is equal to position minus origin, and rectangle is equal to new rectangle int top left dot x. We're just casting these as int top left dot y because that gives us our position values. Texture, remember that can be null, so we'll just do question mark dot width. So that turns, if that doesn't exist, that's nullable int. So if that is, our width will just be 0. Texture question mark dot height. If that's null, we'll just set that to 0. Okay, so what is this top left? The origin, we usually set that up to be the center of our sprite. So position 3, 4, if your origin is on the center of the sprite, that's very different than if your position is 3, 4 and your origin is at the top left. Our rectangle goes from the top left of the sprite to the bottom right. It does not use our origin. So we need to take our position value, subtract our origin, that gives us our top left location of our sprite, and then the width and the height will give us our bottom right. Okay, so that's just a quick update. I decided to add this to the physical entity after I did this video. You know, after you finish a project and then you look back and you can find you can make stuff a little bit better. So I added that to the physical entity because any class we can add that will derive from this, that will perform the very same logic. So in order to prevent repetition, I'll just add that to the update rectangle. I'll add that method to the physical entity class. Okay, so that's it for this video. I hope you enjoyed it. Stay tuned for the next video. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to discuss the text entity class. This is going to be related to the physical entity, so there's going to be some duplication here. I do not want to create a derivative of the physical entity for text entity, because there's a few things I want to end up doing in the future. So create a new class, text entity, and it's going to be a public class, not abstract, and it's going to be a derivative of game entity, not physical entity, but it will be iPhysical. Alright, and implement all the missing members. Okay. So we have a few properties. I'm going to rearrange some stuff here. I like to keep properties after the constructor, private fields above the constructor, and methods after the properties. So let's finish up the properties here. So we have color. This is all related to iPhysical. So we have color, rotation, scale vector, and position. We need, of course, text. We need to have public string text. Text entity can't have a string for setting the text, so we need to have that. This is going to be private set, though. So that is the text, and then we have rectangle and origin, the same as we did with physical entity. Let's get rid of that white space there. So public rectangle, get and private set. And then we need the origin again, public vector2 origin, get and private set. Now we need two event handlers. The same thing that we had for the physical object, we need content loaded, but we need another one for a text updated. So public event handler, content loaded, and public event handler, text updated. Okay, so once those are done, we need to add a few private fields at the top here. Private vector2 underscore measure string. Now this is going to hold the x and y width and height of our string in pixels. So it's measuring the string. Private read only string underscore sprite font asset name. So that's going to hold our asset name of our sprite font. Same thing we had with physical entity where we had our texture name. And then private sprite font underscore sprite font. Alright, now our constructor. Our constructor is going to have our asset name, which is the sprite font asset name, our text, our color position, color and position, scale, and that's all we need. Okay, so that is all we need for that constructor. I am going to actually set the position to be an optional parameter. Now, the way you do this with structures like this, we need to have default and the structure. So default vector2 and, well, actually, it changed the order of where I wanted it to be. Float scale should be at the end there. Float scale is equal to 1.0 f. And string text, that should be before the color. Alright, so let me see if I have this. So we need string. The order that we want this is string, the asset name, string text, color, vector2 position, defaulted to vector2, and float scale of 1.0. So that's all good. I'm going to rename this to asset name. Underscore sprite font asset name. Okay, so that is renamed to asset name. So that is our constructor. So we set up our asset name. Then we need to set our text is equal to text, color, position, scale, and we want to set the scale vector. It's equal to new vector2, scale. Alright, so we got sprite font asset name, text, color, scale, position, and setting up the scale vector. Okay. we're going to set up the load content method like we did with the physical entity. So public void load content manager. We're going to need to add using Microsoft.xna.framework.content. So content manager content. And same thing, if not string.is null or white space underscore sprite font asset name. So if it is not null or white space underscore sprite font, so equal to content.load sprite font underscore sprite font asset name. Next, we're going to call something we haven't made yet, measure text and update text. Alright, once that is done, content loaded !dot invoke this and event args empty. Alright, now we're going to set up the unload content method. Public virtual void unload content underscore sprite font is equal to null. That does not implement iDisposable, so we do not need to call dispose. Rectangle is equal to new rectangle. Int position dot x int position dot y 0 0. We don't have a text string anymore, so we can't measure that. So it'll be 0 0, and origin will be vector2.0. Okay. Now there are cases where you want to move the text from one position to another. And that's all fine. But when you move the text, we want to update our rectangle. Just like when you move our object, our rectangle has to be updated as well. So I'm going to have it as a move method. So public void move vector2 position. So we're moving it to this position. So position is equal to position. Then we call update text, which we have not made yet. Let's go ahead and create that now. So update text, we're going to update our rectangle and set up our origin based off of our measurement. So private void update text. Update text, we're going to provide rectangle is equal to new rectangle. Int position.x, int position.y, and our measurement string, int underscore measure string.x, and int underscore measure string dot y. So measure string x and y, that gives us our x and y pixel values for that string. Origin, we're going to set that up to be the center of our text. Origin is equal to new vector2 underscore measure string dot x divided by 2.0 f and underscore measure string dot y divided by 2.0 f. So that is all the update text is going to do. We are going to have another one. We are going to overload this whenever we want our text to change. Remember, text is a private set here. So we need some way to update the text without accessing that property. So let's set up a public void update text. And we're going to provide the string for our new text value. We're going to set text is equal to text. We're going to measure our text, which we have not done yet. Then we're going to update our text. We're going to call the empty parameter overload to get the rectangle and origin to be updated. Then we're going to call that invoke on text updated. Question mark dot invoke. This event args empty. That way, if anything wants to be notified when text has been updated, they will be able to after that's been invoked. Okay, now let's set up our measure text here. Private void measure text. So this is going to measure our text, and it's very easy to do with the sprite font. So if underscore sprite font is not equal to null, we're going to set underscore measure string is equal to underscore sprite font dot measure string text. Now, text can be null. We can provide null here. Text is a nullable type. So what do we want to happen if text is null? I chose to use the null coalescing operator, question mark, and just provide the empty string if it is null. Because that way it will provide 0, 0. What's position? Get. Oh. So in the properties, change the public vector to position, add the private set there. Okay. So update entity, that is not going to be implemented. We're probably going to save this for beta full release. Empty for now. So it's going to just be empty for now. If we add animation to our text entity, we are going to have to update it in our update entity here. And to draw the entity, if underscore sprite font does not equal to null, and not string dot is null or white space text. So we're going to call sprite batch dot draw string and provide underscore sprite font text position color rotation origin scale sprite effects dot none and 0.0f. Okay, that is it for this class. So we created a few private fields up at the top of the class. Measure string, that is used to measure the x and y pixel values of our string. You know, our string could be hello, but how many pixels does that take up? 150 pixels wide and 30 pixels tall. Sprite font asset name. What is the name of our sprite font content that we want to use? Check out my monogame beginning, the monogame basics video and advanced video to determine how to draw text. Sprite font, the actual sprite font object that will be used whenever we load in our asset. Then we have our constructor that sets everything up. A few of these are provided by the interface, iPhysical. Color, float rotation, float scale, vector 2, scale vector, vector 2, position. Text, rectangle, and origin. Those are new properties we have created just for this class. Text, we need to determine we want to display the text hello. So that gets stored here. Rectangle is used to hold where our position is plus our width and height of our string as a measurement. And our origin just sets the center point of our text. Then we have two events for loaded content and updated text. Whenever we have loaded our content, we'll call that, we'll invoke that. So anything that wants to be notified when our content is loaded, they will receive that invocation. Same thing with text updated. Whenever we update our text from string hello to string world, that they will be notified whenever that happens. Load content here, that just does what we've looked at in the physical entity class. If our asset name is not null or white space, we will load our sprite font, we will measure our text, and we will update our text. And we'll call the content loaded event. Unload content. Sprite font does not implement iDisposable, so we just need to set that to null. We don't need to dispose it. We set rectangle to our position, but our width and height is 0, and our origin to be 0. Move. Whenever we want to move the position of our text from one location to another, we update our position, and then we update our text. Then we call update text, where we set up our rectangle and our origin. You could actually call this from unload content. So if you want to do it that way, make sure you do underscore measure string is equal to vector2.0, and all you need to do after that is call update text. And then there you go. So update text will set our rectangle and our origin based off the measure string and our position values. That's the parameterless method. Update text has an overload that takes one parameter, and it is a string value of text. So if we want to change the text of this string from hello to world, we need to call update text by passing in world. So our text gets set to the different text we want to display. The text is different. World is going to have a different measurement than hello, so we need to remeasure our string. Then we need to update our rectangle and our origin based off that new measurement. And then we call that event, so anybody that wants to be notified when the text is updated, they will. Measure string. If we do have a valid sprite font object, we can measure string by calling the sprite font.measureString method. Now, if text is null, we use the null coalescing operator and provide the empty string. You can provide something here if you want to have debug purposes, like not found or something like that. I just chose to use an empty string. Update entity, that is blank for now. We will add stuff later on if we need to. if we ever have our text update by having an animation, we'll need to have that there. Draw entity, we need to check to see if our sprite font is not null and our text is not null or white space. Then we just call spritebatch.drawString with the provided arguments, and we are good to go. So that is it for the text entity class. Next video, let me bring this up here. Next video, we will start looking at the rectangle collision states. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. This is going to be a very quick video. It's going to be just like the interfaces. We're going to set up our rectangle collision. Let's right click our collision folder. Let's go to add class. And we're going to call this rectangle collision side. Now this is not going to be a class. It's going to be enum. It's a public enum. So replace class with public enum. And we're just going to set up our enum values in this video. None, we don't have a collision. No sides are hit. Left, our left side is hit. Top, our top side is hit. Right, our right side is hit. And bottom, our bottom side is hit. So that's it for this video. I hope you enjoyed it. Stay tuned for the next video where we will discuss the rectangle collision point. That's going to be an enum as well, but it's going to have a public static class to go along with it. That's going to be an extension method, or an extension class. And we're going to do a lot of switch cases and just setting it up what to return from the enum. So stay tuned for the next video. Thanks for watching. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. In this video, we're going to discuss the rectangle collision point enum. So let's right click our collision folder. Let's go to add class, and we're going to call it rectangle collision point, and replace class with public enum. So these are going to hold our points of collision. Last tutorial we discussed the side. We only have 4 sides of a rectangle, but we have more than 4 points of collision in a rectangle. So let's set none. We don't have a collision. Top, left, bottom, right. But those are sides. We're also going to have those combined. We're going to have top left, top right, bottom left, and bottom right. So not only do we have sides for the collision point, but we have corners for the collision point as well. Alright. Since those last tutorial and this tutorial are very short, I'm going to combine this with the rectangle collision point extension class. So let's right click our collision folder and let's go to add class. We're going to call this rectangle collision point EX, or whatever your naming convention is for extension method classes. It's going to be a public static class rectangle collision point EX. So the first thing we need to create is we need to somehow get from left and top, we need to combine those to top left corner. And we need to do the same for all the other corners as well. So let's set up a public static rectangle collision point. We're going to call this combine. We're going to combine 2 points into a corner. This rectangle point, source, and rectangle collision point, target. So we're going to combine source and target into a corner. So if two opening parentheses, source is equal to rectangle collision point dot left, and target is equal to rectangle collision point dot top, after the first closing parentheses, or opening closing parentheses, and then in between those parentheses, source is equal to rectangle collision point top, and target dot rectangle collision point, or is equal to rectangle collision point left. And I'm going to move this to a new line here. Closing parentheses and opening closing the curly brackets there. We're going to return rectangle collision point top left. So what we did here is we checked to see if source is left and target is top, or source is top and target is left. We are going to return top left corner. We need to do the same thing for all the other corners. So we can copy this if block here and paste it below. And change, so we have if source is equal to rectangle collision point dot left, change dot left to dot right, and target is equal to top, that's fine. In the second line, we have source is equal to rectangle collision point dot top, that's fine, and target is equal to rectangle collision point dot left, change left to right. And change our return to top right. Now what we can do is copy and paste those two if blocks. And I'm going to separate those so it's easier to distinguish which ones we've done and which ones we haven't. In the first one we pasted, we have left top and top left. Change that to left bottom and bottom left. And our return type is bottom left. In the second if block that we pasted, we have right top, top right. Change that to right bottom and bottom right. And our return is going to be bottom right corner. If none of those have succeeded, we are just going to return no collision. This is only going to be called when we have a valid check. We have checked to see if rectangle collision point is on a side for both source and target. So if they're both on a side, we can combine those. The next thing we want to do is have a public static vector2 get corner normal. Vector2 delta. What this does is we are going to find a corner value of our object, and we want to return a normal for that corner. Var n is equal to delta n.normalize return n. So that just gets a normal of the vector 2 we pass, and that's going to be a corner that we pass. This would be more obvious when we generate this method here. Public static vector 2 get normal. This rectangle collision point bool inside is equal to false. That's going to be an optional parameter, because normal inside is going to be different than a normal outside. Game math video coming up in a future video. Let's switch on our provided point. Okay. Case. If we are at the top, we simply return new vector 2, 0, comma, is it inside? If it is, 1, otherwise negative 1. Basically, imagine you are holding up your phone or your keyboard, or you're looking at your keyboard, and at the top of your keyboard you have your number keys or your function keys. So put your finger on one of the numbers or function keys, and then move your finger towards the top of the keyboard and move it past the keyboard. Now move that back to the keyboard. As soon as you are over the keyboard, that's the normal we want. The normal will return the opposite direction of where you are coming from. So if you're coming from the top, you're going positive y. So our normal is going to be the opposite, so it's going to be negative y, and the normal has a length of 1. That is this here. We are not on the inside. Now, hold your finger to one of the number keys, or letter keys, and then start moving your finger towards the top of the keyboard. Right before your finger passes the top of the keyboard, that is another collision where we are inside that keyboard, but we are moving our finger negative y. So our normal needs to be the opposite. It needs to be positive y, and normals have a length of 1. That's where inside is true comes into play. So there will be a video that you will see that will discuss that, give you more visual of what is going on. Okay, case left, return new vector 2. If it's inside, we're going to return 1. Otherwise, we're going to return negative 1 and 0 for the y. Case bottom. If it's bottom, we are going to return new vector 2. If it's the inside, we're 0 for the x. If it is inside, we're going to provide negative 1. Otherwise, we're going to provide 1. Case. The right corner. Return new vector 2. If it is inside, we are going to provide negative 1. Otherwise, we're going to provide 1 and 0 for the y. Now is where the corners come into play and where this method we created before comes into play. Case rectangle, top left. We want to test the top left. Return, get corner normal. New vector 2. If it is inside, we're going to provide -1 for the x. If it is outside, we're going to provide +1 for the x. For the y, if it is inside, we're going to provide -1. If it is outside, we're just going to provide +1. So that is top left. Remember, a vector has to be a length of 1. So a 1, 1 vector does not have a length of 1. That's why we need to normalize our corner vector. Case. We're going to test our top right. So our top right corner. Return, get corner normal. New vector 2. For the x component, if it is inside, we're going to return 1. Otherwise, we're going to return -1 for x. For y, if it is inside, it's going to be -1. If it is outside, it's going to be 1. Case. Bottom left. Return, get corner normal. New vector 2. If the x is inside, we're going to get -1. Otherwise, we're going to get 1. If y is inside, we're going to get 1. Otherwise, we're going to get -1. Case. We're going to get the bottom left, bottom right corner now. Return, get corner normal. New vector 2. Inside 1, -1. Inside 1, -1. Default. We did not satisfy any of those conditions. We're going to return vector 2.0. So that is it for that method. We're going to have one more method here. Public static rectangle collision side. We're going to get a rectangle collision side from our rectangle collision point. Get collision side. This rectangle collision point. Source. Switch our source. Case. Rectangle collision point bottom left corner. And case. Rectangle collision point left. And case. Rectangle collision point top left. We're going to return the left side. Case, rectangle collision point bottom right. Case, rectangle collision point right. Case, rectangle collision point bottom right, or top right. Return collision point right. Collision side right. Case. Collision point top. We're going to return rectangle collision side top. Case. Collision point bottom. Return collision side bottom. Default. Return no collision. Alright, so this just converts our point to a side. Now the corners are a little bit iffy, depending on what you want to do. Like the bottom left, bottom right, and top right. I chose to set those up to be the left or right sides, not the top or bottom. Depending on what your situation allows, or if you have a better thing you want to do for this, feel free to do that. So that is it for this tutorial. I hope you enjoyed it. Next video, we are going to discuss the movable entity class. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to discuss the movable entity class. So let's get started. We want to right-click our game object folder and go to add and add a class. And we're going to call this movable entity. And it's going to be a public abstract class. Movable entity, and it's going to derive from physical entity, and it's going to implement iMovable. Okay. So the first thing, when an object can move, we want to set it up, in this framework, we want to set it up to restrict the movements. For example, if you have let's take a look at the classic platformers. You have a platform, and you have a monster walking on that platform. You want to restrict that monster's movements so it does not walk past the edges of the platform. So once it moves to the left, and once it reaches to the left edge of the platform, it looks to the right and starts moving to the right, and it goes back and forth. So we need to restrict the movements of our object. And we're going to use bounds to handle that. So I'm going to create a private rectangle, and we'll need to add using Microsoft.xna.framework. And it's going to be a nullable type, so we'll add just a question mark there, _bounds. And that just, we're binding our object to a certain rectangle. So it cannot go outside of that rectangle. Alright, now let's implement the interface. So I'm going to use ReSharper and implement missing members. And I'm going to implement the values for the interface, which are float angle, it's going to be a public property, float angle, public float speed, public vector2 velocity, and public vector2 acceleration. So you need to do that if you do not have ReSharper or anything that can add missing members in a few clicks that you saw me just do. So angle, I'm going to set up a private set. And I'm going to set speed to have protected set. And velocity is going to be private set. And max speed, acceleration is going to be protected set. Now we want to have another property for public float max speed. And that's just going to be get only. Okay. So now let's add methods, and then we'll need to add the constructor after that. So let's add a method that will update the velocity. Whenever our speed changes or our angle changes, we need to update our velocity. So we're going to set that up to be a private void update velocity. And that's going to be called whenever our speed changes or our angle changes. We'll just call update velocity. So velocity is equal to new vector2 cast this as a float, speed times math dot cosine the angle. And then we need to do the same thing for the y component. So cast that as a float, speed times math dot sine the angle. So that just updates our velocity. So we don't have to constantly repeat that code that you see. We'll just call that method update velocity. Okay. So let's go and create the actual constructor now. So after our private field and before our properties, let's add our constructor. It's going to be a protected constructor, movable entity. We're going to provide the color, vector 2, position, float angle, float max speed, string, actually I'm going to move that to a new line, string texture name, float rotation is equal to 0.0f, float scale is equal to 1.0f, rectangle bounds, and that's going to be defaulted to null. It's a nullable type, so rectangle question mark bounds is equal to null. Okay. Then we need to call the base constructor, so base open parentheses. We need to pass along the color that we provided, position, texture name, rotation, and scale. Okay, and then we open and close the curly braces. We set underscore bounds is equal to bounds, angle is equal to angle, speed is equal to 0. Speed is our initial speed. Our max speed is what we provide. So max speed is equal to the property max speed is equal to our parameter max speed. Acceleration is equal to vector 2 dot 0. Okay, and the last thing we want to do is call update rectangle. So that is a protected method in physical entity. So just call that. Okay, so that's it for the constructor. So now let's move on to the actual other methods as well. So we already have update velocity. Now, in some cases, if you have for example, let's say you have a power-up. And a power-up, let's say you're making a game and you have power-ups and you're fighting enemies. One of those power-ups might be to throw up an invisible barrier where your enemy cannot escape for, let's say, 5 seconds. And then that object's just stuck there. So we want to have this enemy is not going to be defaulted to be bound by any limitations. Or maybe it is, and you're just restricting that bounds even further. We want to have another method to bind the enemy, and then we want to have a method to unbind it when that power-up is finished, for example. So public void bind entity rectangle bounds. We're going to bind it by bounds. Underscore bounds is equal to bounds. Public void unbind entity. And that's going to just set underscore bounds is equal to null. Okay. This next method. When an object is... This is a movable entity, so it can move. When the object is static, it's not moving at all. The initial process, when when it goes from not moving to moving, we want to have that in a special case. So we're going to call that start. Public void start. Nullable float initial speed is equal to null. That sets it up to be initial speed. If you want it to initially start at 7 instead of 0 and slowly accelerate. We're not using acceleration in the alpha series. It's there, so it's easily extendable. You can just use it when you want to, but we're not using it right now in the alpha version of the series. Okay, so going from not moving to moving, that process, we're going to call that start. So we're going to check to see if we have a speed already. We have already started moving, so we don't need to do this anymore. If speed is greater than 0, just return. Otherwise, if initial speed does not equal to null, so we have provided an initial speed. Speed is equal to math.min initial speed.value or max speed. If the maximum speed the object can travel is 10 and we provide 100,000, we want to make sure that it only goes to the maximum speed that it is allowed. Else, if max speed is greater than 0, speed is equal to max speed. So we did not provide the initial speed, so we are moving by the maximum speed that object can move. Again, once speed or angle changes, we need to call update velocity. That's why we created that method, otherwise we'd have to do this multiple times, and code repetition is a very bad thing. Now, code repetition in the case of calling a method, that's, there's no way around that. But code repetition in this case, if we want to change a way that the velocity is updated, that's why code repetition is a horrible thing. Because all we have to do is just change it in this method, and that's being called elsewhere. If we did actual code repetition of this line here, and we come later on, and when we do the beta series, we might change the way that the velocity is updated. Okay, now we need to update it multiple times instead of just updating it once in this method. Okay, so that is start. Now let's do the opposite, where we're going from a moving state to a stopped state. In that process, we're going to call that stop. Public void stop. Stop, obviously, we're going to set the speed to 0. And we can call update velocity, or we can just set velocity is equal to vector 2.0. I'm going to call update velocity in this case here. Either way is fine. We know that's going to be 0, but if we need to do other things when we update our velocity, it's a good idea to just call that method. Okay. Now, angle here, that is a private set. We're going to change our direction by using the public accessible method. So public void change direction. We need to provide the new angle, float angle. So our angle changes, again, whenever our speed or our angle changes, we need to update our velocity. There are two more methods I want to implement, and this is the case where if we want our object to speed up or slow down. Again, we're not using the acceleration at this time, but there might be some additional cases where you have status effects, and that not only are you accelerating, your speed is increasing but due to the acceleration. When we eventually do use that, if we have some kind of power up or status effect that we do want our object to speed up or slow down, we need to have that as well. Public void speed up float delta speed. If delta speed is less than or equal to 0, return. Speed up needs to be positive. Speed is equal to math.min speed plus delta speed and max speed. We still want to limit our maximum speed our object can travel. Our speed is updated, so we need to update our velocity. Now we need to do the opposite, slow down. Public void slow down float delta speed if delta speed is less than or equal to 0, return. We want to slow down by a positive amount because we'll just subtract it. Speed is equal to math.max 0, speed minus delta speed. If we're going a speed of 1 and we want to slow it down by a speed of 5, we cannot go a negative speed. If you want to have that capability, just delete this check. Or not delete that check, but delete this math.max check. So if you want that functionality, just delete math.max. If you want to have your object travel a negative speed, just get rid of this here. Our speed changed, so update velocity. Okay, the next thing we want to do is override the update entity method. So I'm going to use resharper, overriding members, and it's going to be the update entity. And that just overrides the update entity method. So this is a movable entity. When our entity updates and it's movable, we need to update our velocity and our position. Velocity is equal to velocity plus vector 2.multiply acceleration float game time dot elapsed game time dot total seconds. Position is equal to position plus vector 2.multiply velocity comma cast it as a float game time dot elapsed game time dot total seconds. These are the physics formulas for updating the position and the velocity. And that is position has no setter. So in our physical entity, we have our vector 2 for position. It's a property. Let's set that to protected set. Now that we have a condition where we want to set that, we need to update our access levels and set protected set. Update rectangle. Our position changed, so we need to update our rectangle. Okay. Now, our object, our movable entity object, can be bound to a rectangle. We need to check those bounds so it does not go through that it cannot just escape those bounds. So let's set a private void check bounds if we are not bound, which means underscore bounds is equal to null. We just simply return. We don't need to check our bounds. Var temp position is equal to position. Var collision point is equal to rectangle collision point dot none. We have not collided yet. If rectangle dot left is less than underscore bounds dot value dot x, that means we have passed through the left side of our bounds. Temp position dot x is equal to underscore bounds dot value dot x plus origin dot x. Remember, our position is influenced based on our origin. If our origin is the center of our object, we need to update our position appropriately. Because with 3, 3, that's going to be a different location if our origin is at the center of the sprite versus if it's on the top left. Collision point is equal to rectangle collision point dot left. We have passed through the left side of our bounds. So I'm going to do the same thing for the right side. Now, we cannot have a collision on both the left and the right side, so I'm going to do else if rectangle dot right is greater than underscore bounds dot value dot right. So if the rectangle is greater than the bounds, we are going to set the temp position dot x is equal to underscore bounds dot value dot right minus origin dot x. And then we'll set the collision point we'll set that to be at the right side. Now, we can't have both a left and a right collision at the same time, but we can have a left top, left bottom, right top, or right bottom. So what we're going to do here is check the top and bottom, but we're going to combine it if we have a left or right collision. If rectangle.top is less than underscore bounds dot value dot y. So the top of our rectangle is pushing outside of our bounds, so we need to adjust it. Temp position dot y is equal to underscore bounds dot value dot y plus origin dot y. Collision point is equal to collision point double equals none question mark. We're going to set it to the top. Else, we're going to set it to combine. So collision point dot combine. We're going to combine it with the top. So if we have a left or right collision, we are going to combine it with the top, which will give us left top or left bottom, or right top or right bottom. Now, we can't have a top and bottom collision, just like we couldn't have a left and right, so we're going to use else if here. Rectangle dot bottom is greater than underscore bounds dot value dot bottom. Temp position dot y is equal to underscore bounds dot value dot bottom minus origin dot y. We're going to do the exact same thing we did when we tested the top collision. Collision point is equal to collision point double equals none question mark. We're going to set that to rectangle collision point bottom colon collision point dot combine. We're going to combine that with the bottom as well. Okay. So once we tested all of our collisions, this holds our adjustment position. So if our position is 3, 2, and our adjustment is going to be 2, 2, we need to get that difference, which will be -1, 0. We need to go from 3, 2 to the resulting one, which is 2, 2. So 3 to 2, that's -1, and 2 to 2, that's 0 change. So var change is equal to temp position minus position. If change is equal to vector 2.0. If we have not changed, just return. We don't need to do anything else. If we do, let's call hit bounds, which we haven't made yet, but we'll go ahead and do that. We pass in the change vector collision point dot get normal. It's going to be inside. We're bound by a box, so it's going to be inside normal and the collision point. Alright, once we have called hit bounds, we're going to call position is equal to temp position. And whenever our position changes, we need to update our rectangle. In the update entity method, we need to call check bounds. So after this method, let's go ahead and create our hit bounds method, the one we were just calling here. So public virtual void, it's going to be a virtual void hit bounds vector 2 change vector 2 normal rectangle collision point. It's going to be a empty virtual method base implementation do nothing, which will probably extend this in a future release, but for right now it's just going to do nothing. And it's going to be an optional method, so we don't want to make it abstract. Alright, save this file, and that is it for this file. So hopefully this tutorial ends out to be well put together. I had to split this up into 4 parts. And hopefully everything will just come nicely together. If there's a few hard cuts, just be aware of that. In the update entity method, we need to call check bounds. So I hope to see you next time for the video that will discuss collision. Thanks for watching. Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video we are going to discuss the collision class. And in this class, this is going to be responsible for checking collision and also performing collision detection and returning a normal collision result. So if 2 objects collide, what is the normal for that collision? And we're going to use that when we do vector reflection, which we will use in our paddles game. So let's right click our collision folder and let's go to add class. Let's call this collision. And I'm going to minimize the solution explorer. It's going to be a public static class. This is just going to help us check for collision, so we do not need to make an object to this, so we're just going to make it static. Now the very basic thing we want to do is check to see if one object collides with another object. And the easiest way to do this is to check for rectangular collision detection. In a future video, and when we get this in beta and final release, we're going to check more than just rectangle collision detection. But for now, this is just the basics of what we're going to be doing. So public static bool, and collision only works, in this case, it'll only work for objects that can move. So we're going to do rectangle collision. And we're going to provide movable entity A and movable entity B. We're going to set those up as the parameters. And what we're going to do is we're going to check rectangular collision detection by using the rectangles of those entities. So we're going to return rectangle or rectangular collision. A dot rectangle, B dot rectangle. And we're going to create another method here, public static bool rectangular collision. It's going to accept rectangle A and rectangle B. And it's going to return A dot intersects B. And we're just going to adjust the name in here so it works. Okay. So we call rectangle collision, and we provide two movable entities to check. And that calls rectangular collision with two rectangles. And it just checks to see if those two rectangles are collided. The last method we're going to create for now is the rectangular collision that we want to retrieve a normal based on the collision. So we're going to do public static bool rectangular collision, movable entity A, movable entity B, out vector 2 normal. So it's going to be a public static bool rectangular collision, and the parameters will be movable entity A, movable entity B, and out vector 2 normal. This is going to guarantee that we're going to get a normal. It could be vector 2.0. That could be our normal. But it will provide a normal. Normal will be vector 2 in the case where no collision has occurred. So it will return false and vector 2.0. Okay. So let's set that condition up. Normal is equal to vector 2.0. Alright. If not rectangular collision A dot rectangle and B dot rectangle. So if it did not collide with another rectangle, we're going to return false. So if there's no point to continue, there is no rectangular collision, so we return false, and we return the output will become vector 2.0. If that is not the case, we continue. So the way we continue with this is we get the delta position. A position minus B position. We get the change of position. We get the delta of x and delta of y. So delta is equal to A dot position minus B dot position. Then what we do here is we need to get the absolute value of x and y. And we do that because there's a few cases where we want to get the absolute value in our checks. And we do this before we do our checks in order to not do repeated processing. Now, if you do absolute value of a variable 4 times, you don't need to do that. You just create a variable to hold that data and then just check that variable. So we're going to get an absolute value of x and y. Var abs delta x is equal to math.abs absolute value delta.x. Var abs delta y is equal to math.abs delta.y. Okay, so let's look at the first check. Collision on the right side. If delta.x is greater than 0, so the delta, the change of x between one object and the other object, if that is greater than 0, that means the change is going to the right direction. So we are getting a collision on the right side if that is true, and the absolute value of delta y is less than b.rectangle.height divided by 2.0. So that will check if the absolute value of the delta y, if that is less than height divided by 2. So since we're using the origin as the center of our object, if, for example, let's say the delta y, the absolute value of delta y, is equal to half the height, that would mean that our object is at the bottom right corner of our other object. So object A is going to be at the bottom right of object B, since we're using the center point as the origin. Which that's a completely separate test case. We're testing right, bottom, left, and top. And we're also checking to see if the collision is on the corners, which this condition would satisfy that. If that was false, it would be a corner collision, not a side collision. So that is the explanation for this. If using vector 2, using the center point of the object for our vector origin, that would mean our rectangle height divided by 2. That would be the center point of that rectangle. If that is less than that, then it's a side collision. If it's equal to that, it's a corner collision. If it's greater than that, it's a corner collision. So that is why we check to see if it's less than the height divided by 2. Now, I also added additional to check. This is not required. I just decided to throw this in there to make it a little bit more better. But it is not required. You can leave this part out. A.velocity.x is less than 0. That means it's traveling to the left. If it's traveling to the left, it will have a right side collision. If it's traveling to the right and it hits that point, no collision is going to occur because we're already traveling to the right, so we don't need to check that. So if all this is true, normal is equal to new vector 2, we need to point in the right direction. 1, 0. We need to have a normal that points in the right direction. It's a right side collision, So we need to point the normal to the right side. Okay, left side. These are all going to be similar. If delta.x is less than 0 and absolute value delta y is less than b dot rectangle dot height divided by 2.0 and a dot velocity dot x is greater than 0. We are traveling to the right. Normal is equal to new vector 2. We need to point it to the left, which is -1 comma 0. And make sure you do and between delta x is less than 0 and absolute delta y is less than b dot rectangle dot height divided by 2. Okay, so that is the left side. Now let's look at top and bottom. Top side. If delta dot y is less than 0, we are moving upwards, and absolute delta x is less than b dot rectangle dot width divided by 2.0 and a dot velocity dot y is greater than 0. Normal is equal to new vector 2. We need to point upwards. 0 comma -1. Okay. A dot velocity dot y is greater than 0. That means we'll be moving downwards. Okay, so bottom side, if delta dot y is greater than 0 and absolute delta x is less than b dot rectangle dot width divided by 2 and a dot velocity dot y is less than 0. We are moving upwards this time. Normal is equal to new vector 2, 0 comma 1. So delta y is greater than 0. We are at the bottom edge. It's a positive delta y, so it's pointing downwards. And then we are moving upwards to the bottom side. Okay, now we're going to check all corners. And instead of testing for equality, I'm going to test in terms of using the epsilon value. Because testing if something equals 0 when you're dealing with floating point precision, that can become an issue when you have 0.0000000001 when you want to just test to see if it's equal to 0. A pixel value of 0.00000001, we will consider that to be 0. But we're going to use the var epsilon to test it with. 0.1. You can make this as big or small as you want. If, two opening parentheses, math.absolute value delta.x minus negative b.rectangle dot width divided by 2.0. If the distance between the delta x and the negative of the rectangle's width divided by 2, if that is less than epsilon, then we have a corner collision. And math.absolute value delta.y minus b.rectangle.height divided by 2.0 is less than epsilon. After the first closing parentheses, add an or. And I'm going to add this to a new line. Opening and closing parentheses again. And now we're going to do this 3 more times. Math.abs delta.x minus b.rectangle.width divided by 2.0 is less than epsilon. And math.abs delta.y minus b.rectangle.height divided by 2.0 is less than epsilon. After the first closing parentheses, add an or and add a new line. 2 more lines to go. Opening closing parentheses, and inside there go to math.abs delta.x minus negative b.rectangle.width divided by 2.0 is less than epsilon, and math.abs delta.y minus negative b.rectangle.height divided by 2.0 is less than epsilon. After the first closing parentheses, add an or, and this is the last line, opening closing parentheses, math.abs delta.x minus b.rectangle.width divided by 2.0 is less than epsilon, and math.abs delta.y minus negative b.rectangle.height divided by 2.0 is less than epsilon. 2 closing parentheses, opening and closing the curly brackets. And that just formatted by itself, and that's fine. Alright, so this is a check to see if any of the corners, top left, top right, bottom left, or bottom right, if any of those have hit, we're going to set the normal. So the new vector 2, delta.x, comma delta.y. Normal.normalize. Return true. So that is it for this. So at the top, we created a method that will handle rectangular collision, the very basic case between one movable entity and another movable entity. And it just calls another rectangular collision by providing their rectangles. The second method checks to see if collision has occurred between 2 different rectangles. And all it does is call rectangle.intersects another rectangle. The third method checks to see if there's a rectangular collision, and if one exists, it will give you a normal. If one does not exist, it will give you a vector 2 for the normal, in this case here. So the first thing we do is we get a delta value. If a collision has occurred, we get a delta value that gets a difference between A's position and B's position. That could be negative 3, 2, for example. Then we need to get the absolute values of those because we want to see if that value is within a certain range. For example, let's look at the right side. If the absolute value of the delta y is less than b.rectangle.height divided by 2, b.rectangle.height is always guaranteed to be positive. It might be 0, but it's guaranteed to be positive. It cannot be negative. So we need to convert absolute value of delta y, and we need to have that for the check. So we do that for all the sides, right side, left side, top side, and bottom side. Okay, now for the corners. This one is a little bit more confusing, and you might want to just check out my video game mathematics video that discusses how to create an algorithm for rectangular collision and retrieving a normal. So this is a lot less confusing than it appears. Let's take a quick look at this. Math.abs, delta x minus negative b.rectangle.width divided by 2 is less than epsilon. That is equivalent, I'll just write a comment up here. This is equal to delta.x is equal to negative b dot rectangle.width divided by 2.0. That is equivalent to that. It just uses the epsilon to check to see if maybe this won't become exactly this. If delta.x is equal to, let's say, 37.32, but this produces 37.33, this will not be equal to. But you get the idea. This might not be exactly this. So we use epsilon to check to see if it's within a certain error. If it's within 0.1 of that, then we are fine. So delta.x is equal to negative b.rectangle.width divided by 2. So negative width, that is the left corner. Remember, delta x, that gets the delta position between A and B. If A is to the left of B, delta.x will be negative. So each one of these sections checks top left, top right, bottom left, bottom right. And if any of those is true, we get a normal based off the delta values, and then we normalize it. Remember, a normal has to have a length of 1. Delta.x and delta.y, that can be 300, 200. That won't have a length of 1, so we need to normalize it before we return. So that is the collision class, and that is how to get a normal from a collision using rectangular collision. I hope you enjoyed that. If you want to learn more about that, check out the video game mathematics video, which will discuss how to get an algorithm for rectangular collision detection and retrieving a normal. So next video we will discuss input mode. I hope to see you next time. Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video we are going to look at the input mode enum. So this is going to be a very short video. So right click the input folder and add a new class and call that input mode. And I'm just going to make that window very small. So this is going to be a public enum instead of a class. Public enum input mode. So this is going to hold the mode of our input. And what does that mean? That means that the mode where if our key was a new key press, or if it's held, or if it's old, or if it's released. So those are the values that's going to be handled. Released, old, new, held. So when a button, let's say the space bar, if I hit the space bar, that's going to be new. The next game loop, I'm still holding my finger on the space bar, so now that becomes held. The next game loop, I release the space bar, now that is released. The next game loop, it's going to be old, because it's an old release state. It's an old input. It isn't newly released. It's old now. So those are the 4 different modes that an input can be in. So that's it for this video. Next video, we will take a look at the input state. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to implement the input state class. Now this class is going to be a wrapper for all of our input states. For right now, it's just going to be wrapping the keyboard state, but when we add mouse support, it'll be using the mouse state as well. So let's go ahead and get started. It's going to be a sealed class. We don't want to override, don't want anybody to override. So public sealed class input state, and it's going to implement iFreezable, where we want to be able to freeze our input state to not worry about getting any more input. If our entire game is frozen, we don't have to constantly pull the input system for any inputs. Public. So let's set up the properties here. Public keyboard state. So the keyboard state, we're going to have to use using Microsoft Dynamics Framework.input, and go ahead and add using Microsoft Dynamics Framework at the top as well. So the keyboard state, this is built into the monogame framework, and that just represents the current state of our keyboard. So I'm going to call this property keyboard state. It's going to be get and private set. Alright. Now I'm going to implement the iFreezable property. So public bool is frozen, get and set. Alright. Now at the top, I'm going to implement the constructor. So public input state. I'm going to set the keyboard state is equal to keyboard.getState. When I generate the object, I want the keyboard state to automatically be set already. So we set that by calling the keyboard.getState is frozen is equal to false. It's not going to be frozen at this moment. The last thing we want to do is have an update method. Public void update game time. Even though we won't use the game time right now, we might in the future. So if our input state is frozen, we are simply going to return. We're not going to do anything. Otherwise, we're going to do exactly what we did in the constructor. Keyboard is equal to, or keyboard state is equal to keyboard.getState. And that is it for this class. So this is a sealed class, so we don't want anybody to override this. It's going to have 2 properties, a public keyboard state, and keyboard state is built into monogame. you'll need to add using Microsoft.x native framework.input. The input state implements iFreezable, so we need to have another property for public bool is frozen. Then we have a constructor that sets the keyboard state and is frozen values. The last thing we have is a update method, and that just sets the keyboard state to the current keyboard state unless the object is frozen, which if it is frozen, it does nothing. Alright, so that's it for this video. I hope you enjoyed it. Stay tuned for the next one. Thanks. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we're going to discuss the input system class. So right-click the input folder and create a new class. And we're going to call this input system. Alright, I'm going to make this small. It's going to be a public class. Alright, so let's add the properties first. Public. So the input system is going to have two input states, the current state and the previous state. Input state is called the current state. So public input state, current input state, get and private set. Public input state, previous input state, get and private set. Alright, now let's add the constructor at the top. Public input system, opening and closing parentheses, current input state is equal to new input state, previous input state is equal to new input state. Okay, so let's add a update method here. Alright, so let's add an update method. Public void update. Opening and closing parentheses, no need to provide game time. Current input state dot is frozen. We're going to freeze the current state, and then we're going to set the previous input state is equal to the current state. So this right here marks the previous state as frozen. We're freezing the current state and then setting it up as the previous input state. Next, we need to get the current input state is equal to new input state. Now we need to have a couple methods, one for keyboard press and one for mouse pressing. Mouse button press. Alright, so public input mode get key state. Keys. Now we need to add using Microsoft.x native framework.input. Keys K. Or key, whatever you like to name your parameters. Var is currently pressed key is equal to current input state dot keyboard state dot is key down K. Var is previously pressed key is equal to previous key state dot keyboard state dot is key down K. If is currently pressed key and is not is previously pressed key. If it is not a previously pressed key, return it is a new key press. If is currently pressed key return. It is a held key press. If is previously pressed key, we're going to return it as released. Or, I'm sorry. If not is currently pressed key and is previously pressed key, we're going to return released. If is previously pressed key, if it is not, if not is currently pressed key and is not is previously pressed key, return old. If none of those conditions are met, we're going to return released. If none of those conditions are met, we are going to return it as pressed old. Since we can get rid of this, since that will always be true at that point. Okay. Alright, so that's it for this video. I hope you enjoyed it. Stay tuned for the next video. Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video, we are going to discuss the input class. It's going to be a very small class. So let's go ahead and expand this and right-click input and go to add class, call this input. It's going to be a public class. So the purpose of this class is to combine our keyboard input, our key, and our input state that we worked on previously. So keys is a enum provided in the monogame framework. We can extend on that by using extension methods, but we cannot add any kind of functionality to. First of all, it's an enum, so we can't have references or methods in there. So we have to do this approach, which is input. We add that enum as a property, and we also need to get the state of that key. So we add the key, the key's value, and the input state, and those two combined will give us an input that we could use. And let's start up the properties here. Public keys, we're going to add using Microsoft.xnative.framework.input key get private set. Alright, and then the other property, it's going to be public input mode get and private set. Now we're going to add the constructor public input keys key is equal to key. Now we're going to add a update method here. Public void update input system mode is equal to input system dot get key state key. So this is just a helper class that combines our key and our input mode together. keys is an enum provided in the monogame framework, and input mode is what we just discussed in the previous video. Combining those, we created our input class. And then when we update it, we get its current mode. Alright, so that's it for this video. Next video, we will discuss the keybind class. So I hope to see you next time. Nathan here, welcome back to another video for the PGL2D Alpha series. And one comment I want to make before we jump into the next video is, when you work on a project and then you think you are doing good things, you realize that going back, you can clean things up and kind of trim things out and kind of move things around to make it much better. And that's what I've been doing in the previous videos of this. As I discuss it with you guys, I can see, oh, I can do this better. Before, in the alpha build that I'm basing this on, I had the capability to support mouse input. I did not use that at all. You could not get further. You could not even call that because it didn't fully support it. I just added that for an after the fact for our beta build. So since I'm not using that now, there's no reason to have that in the alpha build. So I have removed the mouse state, everything related to mice in this alpha version. We will add that back in the beta version when I work on the tower defense game. So I just wanted to throw that out there, that after you finish a project, give it some time and then come back and take a look at it. Maybe explain it to a friend. They don't even have to know programming. Just sit down and explain to it, or just sit down and talk to yourself about it. Kind of pretend like you're doing a recording, because that will give you the opportunity to look at it in a different view. Because I'm looking at this in a different view, where I'm showing you guys how to create this, instead of me just actually sitting down and thinking, oh, well, this might be useful down the road, but eventually I don't use it. I add that in the moment, and I don't use it later on down the road. So it's nice revisiting things. So that's always a good thing to do. Okay, so into the actual purpose of this video. We're going to create a keybind class, and that is going to be the purpose for that. Let's right-click input and go to add a new class. So the purpose of the keybind is going to map an action, a string action, let's say attack. A string action attack in quotes. So string value attack. We're going to map that to a list of key presses. You can attack by space, enter, 1, 2, or 3. You can press any of those buttons to attack. So that was what the keybind is going to be used for. It's going to be public class keybind. Let's add our properties. Public string action get and private set. And let's add our another property for public list of input objects. We're going to call this inputs. We're going to call this inputs. Get and private set. Okay, we're going to add a constructor at the top. Public keybind opening and closing parentheses. String action. And we're going to have the ability for the person using this library to add an initial input. It's going to be optional though, so we're going to default that to null. So public keybind. The parameters are going to be action and then input, initial input. That's going to be defaulted to null. So action is equal to action. Inputs is equal to new list of input. If initial input does not equal to null, we're going to add that to the inputs list. Inputs.add initial input. Okay. Let's scroll down and let's work on the methods. Public void update. We're going to use the input system for our updating. Input system. For each var input in inputs. Input.update input system. All right. Public bool check mode. This is going to be used to check to see if any of our inputs for this action have satisfied the current mode we want to check for. Input mode. So if any of the inputs satisfy the input mode we are providing, we're going to return true. So we're going to use link for this. If you do not know how to use link, I did a short video, I think over a year ago now, on my channel. It's a C# video, nothing to do with monogame, nothing to do with XNA. It's a language specific C#. So if you do not know that, go check out my channel for link. LINQ. Let me make a comment for that. LINQ. Link. Language integrated query. So we're going to call inputs.any. Alright, so this is we're going to create a predicate for this. So that is going to check all inputs. Now we need to assign a name for our current input. So I'm just going to use I equals and then greater than angled bracket I.mode is equal to input mode. So this checks if any of our inputs in this list, if any of their modes equal the input mode we're passing, it returns true. Otherwise, it will return false. The last method we want to do is if we want to add additional inputs to our list. So public void, there's no reason to have a list if we can't add more items to the list. So public void add input. Inputs.add input. Okay. So let's do a quick overview on what we just did. So we have two properties here. A string action that controls what we want to name our keybind. For example, attack. We might be able to attack with space or enter or the number 1 key or whatever. Whatever buttons you want to use as the attack buttons, you use a keybind for that. That brings us to the second property, which is a list of inputs. List of inputs. We have one action and a list of inputs. Attack. Attack can be a list of inputs, which could be space, enter, or number 1. Now we have the constructor. When we create a new keybind, we have to provide the action. We have the option to provide the initial input. Next, we have the update method, which uses the input system for updating. It will loop through all input values and update based off the input system. Next, we will check the mode. It will check all input values, all input objects by the provided input mode that we want to check for. It uses the link, which extends the IEnumerable and adds the any method. And we use a predicate to check to see if input.mode is equal to the input mode we pass in. We could have 50 inputs in our list, but only one of those has to be successful. If I can attack by space, enter, or 1, I can just hit space and attack. The enter and 1 do not have to be pressed in order to attack because I'm pressing space. So if any of those have that input mode, we have successfully, it's true. And the last one, we need a way to add more input objects to our list. Alright, so that is it for this video. I hope you enjoyed it. Next video, we will discuss the input map. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to discuss the input map class. So let me expand this. So right click the input folder and add a new class and call that input map. Now the purpose for this class is going to be handling a list of keybinds. It's going to be a public class input map, and the only property it's going to have is a list of keybinds. So public list keybind, keybinds, get and private set. Alright, in the constructor, public input map, the constructor, we're just going to set keybinds to be a new list. Alright. Next, we're going to have an update method. It's a public void update. Keybinds are updated based off of the input system. So we need to provide the input system here. So just like what we did with keybinds when we updated each input, we need to update each keybind based off the input system. So for each var keybind in keybinds keybind dot update input system. So we're just updating every keybind based off the input system. Now we need a way to add a new action to our input map. So an input map is going to be a list of keybinds, but a keybind holds actions. So public void new action. String action input. So a new action, that's going to generate a new keybind based off that action. But we need to check to see if our keybind already exists. Var existing keybind. We don't want to have multiple keybinds for a single action. We want to have a single action have a list, massive list of multiple keys that we need to press. So if we already have an existing keybind, we need to update that instead of generating a new keybind object. So var existing keybind is equal to keybinds.first or default. So first or default, this is going to be using a predicate which we're going to issue a certain test. K.action dot equals action name. So this is going to return the first result it finds if it found a keybind with an action by the provided action that we want to add a new action to. So we call new action, and let's say we call it attack, and we want to add the space bar to that. Later down the road, we want to add a new action called attack, and we want to add the enter key. Now, attack already exists. It's an already existing keybind. It exists by having space initially. We want to add enter. So we need to get the existing one. We need to find out if it already exists. So we use link, we use the first or default, and we issue a predicate that checks every keybind by issuing a test to see if the action name is equal to the name we are providing in the argument. If existing keybind does not equal to null, we need to update that. Existing keybind dot add input else. So that is null. First or default. If that does not find, let's say this list is empty. So we want to add a new action for attack, and we want to use the space bar. So it does this. It does this check first or default. This list is currently empty, so it didn't find anything. Now it returns null. So if it is null, it doesn't exist in this list, so we need to create it. We need to add it to that list. Keybinds.add new keybind action input. So that is how you add a new action to a list of keybinds where we want to update if one already exists. I'm going to create a overloaded method here. Public void new action string action and keys. So we're going to add using Microsoft.xnativeFramework.input keys K. So let's say you want to add a action for attack, but instead of creating the input class yourself, you just want to say keys.spacebar. This will create the input for you. Var input is equal to new input K. Now this will call new action, and it will provide the input that it created. All right, this next one. I have a few comments about this next one. This is going to get all keybinds by a specific action. Public list of inputs. Get keybinds string action name. So we're going to use link, just like what we did here, first or default, and we're going to get the action name. So var keybind is equal to keybinds dot first or default predicate k dot action dot equals action name. So first or default. Remember, if that doesn't find a keybind by that action name, it will return null. So return keybind does not equal to null. Question mark. Keybind dot inputs. Otherwise, we're going to just return a empty list. New list. So my comments about this method. This will never happen. If you want to do a safe check, we're going to have to do a little bit more complex link here. What will never happen? This will never happen where we will have one keybind object with the action name of attack, for example, and then we'll have a entirely different keybind object with the same action name as attack. That will never happen because when we add a new action, it will see if it already exists. If it already exists, it will update it. It will not create a new one. Now, if you want to do a save check, or if you want to support multiple keybinds with the same action name, maybe you want to do that instead. This is what you will have to do. Var keybind. Actually, let's call this var inputs is equal to. Now this is actually going to look like a complex link query. Link to entities query. From k in keybinds. So I'll just do a brief giant overview of link. From whatever you want to call your variable. In some kind of list or I enumerable. From k in keybinds. Where k dot action dot equals action name. So that will give us multiple keybinds by that action. So we get from k from keybinds, and then we limit it by the action name. Okay. Then we need to do a select. What we want to get from these results. Select k.inputs. So we select the inputs. Now, we wrap that in parentheses, and we call it .toList. So that is a safe way to get multiple keybinds by the same action name, one list of inputs. To prevent duplicates, you could also do .toDistinct, .distinct. But be careful, you need to do iComparable to make that work properly. So if you want to get rid of this and you want to support multiple keybinds with the same name, and you want to get one master list of all keybinds by that name, you can do an actual link to entities complex query like you see here. Otherwise, we are guaranteed where that will never happen because we do that check when we add a new action. So we can just call first or default. Okay, so that's it for this video. I hope you enjoyed it. Next video, we will discuss the base screen class. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to look at the base screen class. So let's bring up the Solution Explorer and right-click Screen System and go to Add Class. We're going to call this Base Screen. I'm going to close the Solution Explorer, make that very small. Okay. So this is going to be a public abstract class. So it's going to be abstract because we only want to allow derived classes of base screen. So the screen itself is actually going to be an entity. It's just going to be a container that holds game objects and text objects. But it's going to be an entity in that we can control if it's active or frozen or hidden. It's going to have initialize and updating and drawing. So it's going to be an entity. So this is going to drive game entity. Then we need to add using PGL2D.game object in this. Alright, so let's get started with the properties here. The first property we are going to add is a property that will determine if the screen can accept input. Let's take, for example, we have a loading screen or a transition screen. A loading screen, in our case, will just display now loading, please wait. It might have a little animation to indicate that it's still working. However, we cannot press space or enter or escape or the arrow keys. We cannot do anything. We cannot use the gamepad. We cannot hit any buttons on the gamepad. We cannot use the mouse. We cannot hit any buttons on the mouse or move the mouse around. It will not accept input. So we need to have a property that determines that. Public bool accepts input. And that's going to be get and private set. Get and private set. Okay. The next two things we want to add is they are both going to be Boolean state values that determines if the content has been loaded and if the content has been unloaded. A brand new instance of base screen will not have content be loaded, and a brand new instance of base screen will not have content unloaded. You cannot unload content before it has been loaded. So both of those values will be initially false. When we load all the game's content, we'll eventually set that content loaded to true. And then if in a future game or if a future extension of that class in this PGL2D library, we're going to query that content loaded Boolean value, we have that chance to do that. That gives us the option to, if we want to determine, hey, we just want to check to see if the content has been loaded on this screen. Maybe you want to load it in a background thread, and you'll have to do additional work in the background other than just using that Boolean value. But just for simplicity's sake, if you want to load that screen in the background in a different thread, and then once it's done, you want to load it into your game, only if the content has been loaded. So you check to see if screen.contentLoaded is equal to true, I'll add it to my game. Otherwise, I'll throw an exception or throw a message to the user or retry to load the screen or whatever your exception handling is for that case. So these are the two values we're going to use. Public bool content loaded and public bool content unloaded. They will both be get and private set. So I'll just copy and paste that. The next thing we want to do, we want to have a property that will handle the input mapping just for this screen. A menu system, for example, this isn't for every menu system. For an example, a test scenario, a menu system will only support the up and down arrow keys. We do not need to have an input map for the entire game. That's entirely possible. If you want to do that, you can change the PGL2D library to fit your needs. If you want to keep things separate, you can follow it this way. In this case, the menu system only allows the up and down arrow keys. There's no reason why we need to add more things to the input map. So we are going to have an input map in this class. And then we need to add using PGL2D.input. The next thing is kind of something that I went back and forth of how I wanted to implement this. And I'm probably going to change this in beta and the final release now that I think about it more. But for now, they're two separate things. These two properties are going to hold our entities for our game. The main list is going to hold our game entities when we are referring to sprites and power-ups and game objects. The other list is just going to be game entities where we look at text. What is displayed? How much health you have? How much time has elapsed in the game? What's your score? All those text entities are going to be contained in their own list. Now, I will probably combine those into one master game entity list, because at this moment, text entity derives from game entity. Those are going to be protected access level, and they're going to be list, and it's going to be protected, but the access is going to be get and private set. So I'm going to go ahead and create those. We need to add using system.collections.generic if that is not on your list. Okay. Those are our properties. The entities, that's where, if it's not text, it's going to be in the entities list. Sprites, power-ups, enemies, platforms, whatever. Anything that's not text and it is a game entity will be in this list. Again, it's protected and it's get and private set. Everything that is text is going to be in this list, and it's just a list of text entities. That's the same thing, protected access, get, and private set. All right, let's go ahead and work on the constructor. So the constructor is just going to be accepts input. That's brand new. But this is a derivative of game entity, which provides is frozen and is hidden. So we can actually create a base screen that is initially frozen and hidden to the user. But we will default that to false. And we're going to make this constructor protected. There is no way we want anybody to add a instance of base screen. Protected base screen bool accepts input. That is not going to be optional. You have to say yes or no that this screen accepts input. Bool is frozen is equal to false. It will not be frozen by default. Bool is hidden is equal to false. It will not be hidden by default. So accepts input is equal to accepts input. Is frozen is equal to is frozen. Is hidden is equal to is hidden. We're going to set this to false. We just created the screen. We don't want to request it to be deleted already. So we're going to set that to false. Input map is equal to new input map. Entities is equal to new list of game entity. And text entities is equal to new list of text entities. Okay, so that is it for the constructor and properties. There is no private fields in this class. Next, let's discuss the load and unload content. And in between that, we will discuss the terminate method as well. So let's get started with the load content. Public void load content. It's going to be parameterless, just load content. And that's going to call, this is a base screen. It doesn't know what you're trying to load. one game screen, your loading game screen might only load a picture file for or a sprite sheet for the animation that will be used for the loading animation. And it will also load the sprite font to display the text that says loading, please wait. But in your actual gameplay screen, you're going to have to load your player, your platforms, if it's a platformer, your power-ups, all those things. And in one game screen, it could be a different set of enemies and other entities than another game screen. So at the base screen level, we don't know what you're going to load, but we want to do this in the correct order. So this is going to use the template pattern that we call one method and guarantee the next method is called after that. So we're going to call load entity content. Now we did not make that yet, so that's fine. After that's done, we're going to call done loading content. We didn't create that yet, but that's fine. Load entity content. That is another thing that is kind of a tricky situation. Load entity content. We're pretty much going to guarantee that every screen is going to have to load at least one thing. It's going to be an exceptional case where you create a game screen and you don't load anything. It's just going to be a blank screen. That is going to be very, very, very rare. So I chose to make this an abstract method. If you have other needs, you can make this virtual and just make it a emptyless method body. Just empty. That way it's not forced on the classes that you derive from base screen. It's going to be protected because we don't want outside sources to call this. So protected abstract void load entity content. All right. So if I make a derivative of base screen, I have to implement that method. It's going to be, unless I make another abstract class in between. It's going to be extremely rare where I won't load any kind of content. I'm going to have to, I might just load one piece of text. So I'll need to load a sprite font. But it's going to be extremely rare where I don't load anything. Now this is going to be virtual. Protected virtual void done loading content. And all that's going to do at the base screen level is just going to set content loaded is equal to true. Okay. Next, let's discuss terminate. When your screen terminates, it performs some cleanup. It unloads content if content needs to be unloaded. It will set itself up to be requested to be deleted. It will set that property to true, and that will notify the screen system because it will query that property every loop, and it will notify, hey, this screen needs to be deleted, so I'm going to go ahead and remove it from this list. And then we're going to call base.terminate because that's an actual method from game entity. So public override void terminate. So terminate. We're going to call unload content, which we haven't made yet, but that's fine. We're going to set this to request deletion is equal to true. And we're going to call base.terminate. Okay. Now let's create that unload content. Now you might be thinking, all right, well, we did load content this way, so unload content will be similar. That's not the case. There's a cool trick that we can do. Protected. This is going to be protected virtual. So we're going to have some code in this already. protected virtual void, unload content. There's a trick we can do. We have a list of entities, game entities. Anything that derives from game entity is allowed in this list. One of those classes we have made, and it's called physical entity. And physical entity has content that can be loaded into it, texture 2D. So this is the trick that we can do. For each, var physical entity in entities.ofType. Physical entity. What we are doing, we are looping through every physical entity in our entities list because it's getting that list of type physical entity. So every physical entity in this list, we are looping through that. And that physical entity has its own unload content method. Unload content. There we go. We can do that ourselves because we have that, we know that class exists. We cannot do it the opposite way because we don't know if you want to load a physical entity or a text entity or a different type of entity altogether. We don't know if you want to load that. For unloading, as long as it has a parent of physical entity, we can unload content. Now, what about text entities, you might be saying? Well, that's the same thing. For each, var text entity in text entities. Text entity has its own unload content as well. Text entity.unload content. Now we will set content unloaded is equal to true. Okay. Now for the update and draw methods. The update and draw methods. This is going to be we are going to we're going to seal the update entity method, and we're going to create a new method that every class will need to override. It's going to be abstract, and that's going to be update screen. Remember, this screen is a game entity. We don't want that to be the reference point from now on. Game entity has an update entity method that is called. We want to seal that, and then in the future, for future screens, that will now, the code that we will need to use, we will need to implement, will now be update screen, not update entity. So, protected, sealed, override, void, update entity. This screen is just an entity. If you didn't see that, I needed to add Microsoft.xNative framework at the top there. And you'll need to add using system.link as well. Sometimes if you just get typing and you have ReSharper, all that's taken care of in the background, and I forget to mention that. The first thing we want to do, entities can be requested to be deleted, just like the screen can. The first thing you want to do before you try to update the entities, if any of them are queued to be deleted, delete them. And that's very easy to do. Entities.remove all. And we'll need to add a predicate. And this predicate, we're going to use a lambda expression for this. E e.requestDeletion. So that's going to remove all entities that satisfy this condition, which is entity.requestDeletion. If that's true, it will be removed. If it's false, it will stay in the list. So the same thing with text entities. Remove all te.requestDeletion. Okay. Now, we're going to make things simpler for the other people using our framework. We are just going to provide the list of entities that can be updated. If you have other needs, anything you see here, if your needs differ, you can feel free to change. But I feel like as someone using this framework, just give me the list of entities that can be updated. I don't need to see the list of frozen entities because I can't really do anything with them. I can't update them. So I don't need to worry about looking for that myself. This is supposed to be taking care of that. So var updatable entities is equal to entities.where, another lambda expression, not e.isFrozen. So this is going to get a IEnumerable of every entity that is not frozen, which means they are updatable entities. var updatable text entities is equal to text entities dot where te arrow not te dot is frozen. All right. So we got updatable entities and updatable text entities. Now let's call update screen. Let's pass game time updatable entities and updatable text entities. And we have not created that method yet, so that's fine. Let's go ahead and do that right now. Protected abstract void update screen. Game time. A list. That's another thing that I want to talk about. These are IEnumerable. Entities.where, that returns IEnumerable. Again, this is another thing that is if you document it well, it doesn't matter which way you do this, but I like to convert this to list. It takes some performance hits up front, but I do not know what I'm going to do when I implement base screen or implement other screens. I do not know what I'm going to do 20 games from now. I might loop through this list 100 times. I might, for some reason, for unknown reasons right now, but for some reason down the road, I might want to add something myself to that updatable list or remove something from that updatable list. So I like to convert those to a list. So that's going to be a list of game entity, and that's going to be updatable entities, and a list of text entity, and updatable text entities. All right, that moved it to a new line, and that's good. Okay. Same thing with drawing. The same thing we did for updating, we want to do the same thing with drawing. So protected override void draw entity. Game time, sprite batch. We need to add using Microsoft.xnay.framework.graphics. Sprite batch All right, let me scroll down here, move my mouse. Same exact thing, except we're not going to remove anything. So, var drawable entities is equal to entities.where lambda not e.isHidden .toList var drawable text entities is equal to text entities.where lambda te not te.isHidden .toList. We're going to call draw screen game time sprite batch drawable entities and drawable text entities. Let's go ahead and create that method now. It's just going to be the same thing as update screen. Protected abstract void draw screen game time sprite batch list of game entity drawable entities and list of text entity drawable text entities. Okay, so the last thing we want to do is we want a way to add an entity. These are protected. So by default, it's going to be protected get only as well. We want to have a public way to add entities. Public. And the reason we're doing this is we have one method. At this time, text entity is a game entity. So we're just going to have one method. Game entity. That is going to determine what list it goes into. That way, the user won't have to call, all right, for these entities, I need to call add entity. For this entity, I need to call add text entity. It just, as of right now, a text entity is a game entity. So there's no point to have these methods split. Var text entity is equal to game entity as text entity. Oops. Semicolon. If text entity does not equal to null, we will set text entities.add. We will set this as a text entity. Else entities.add game entity. Alright, so that's it for this video. I hope you enjoyed it. This is actually take 2 of my video for this. I'll explain in the looking back why I had to redo this video. But I hope you enjoyed this video and stay tuned for the next ones. And I'll see you next time. Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video, we are going to discuss the Screen System class. So let's expand the Solution Explorer here and right-click Screen System and add class. I'm going to call this Screen System. Now I'm going to close the Solution Explorer, make that smaller. This is going to be a public class, Screen System. And a screen system is just going to it's going to hold a list of screens, and it's going to handle things for us in terms of updating and drawing, adding and removing screens. So private read-only list of base screen, we're going to call this underscore screens, is equal to new list of base screen. Alright, this class is just going to be responsible for updating, drawing, adding, and removing screens. So let's work on that. Public void update game time. And we need to add using Microsoft.x data framework in our project or in our class. When we update, if underscore screens dot count is equal to 0, we can return. We don't need to do anything. Otherwise, we're going to call underscore screens dot remove all. We're going to remove all screens that have been requested to be deletion. So a predicate screen dot request deletion. We're removing all screens that have requested to be deletion. Okay. Once those are removed, we can update all the remaining screens for each. Var screen in underscore screens dot where. Screen, predicate screen, and not screen dot is frozen. So if the screen is not frozen, we're going to update it. Screen.update. Game time. Alright, we're going to do the same thing for drawing. Public void draw. Game time. Sprite batch. We need to add Microsoft.x framework.graphics. Sprite batch. So we're drawing. For each var screen in underscore screens dot where predicate screen not screen dot is frozen or is hidden. Screen dot draw. Game time and sprite batch. Alright, there's a few more things we need to do is add and remove. And we need to do one more thing, which is actually loading the content of the screen itself. So public void add screen base screen dot initialize underscore screens dot add screen. So that adds the screen. To remove it, public void remove screen base screen. We're just going to call screen dot terminate. The last thing we need to do is load the screen's content. Public void load screen content. For each var screen in underscore screens dot where predicate screen not screen dot content loaded. We're going to call screen.load content. There's no need to load content multiple times, so we check to see we only get a list of screens where we have not loaded content. So that is it for this class. This is responsible for updating, drawing, adding, and deleting. And part of that updating is loading the screen content. Alright, I hope you enjoyed this video. Next video, we will discuss the iControllable interface. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we're going to create the iControllable interface. Now this interface is going to be used for when we want to mark something as controllable, which we'll need to provide the input map, and it needs to have a method to handle input. So let's expand our Solution Explorer, right click Input folder and go to Add Class. We're going to call this iControllable. Alright, I'm going to make this a public interface iControllable. It's just going to have an input map, get void, handle input. Now, for handle and input, we are going to get a list of available keybinds, and just like when we update, we need to have a reference to our game time. So list keybind available keybinds. Because if we handle input but the up arrow key is not available, we cannot process the up arrow key. Game time. Now we need to add using Microsoft.xna.framework game time. Okay, so that is it for the interface. It's the iControllable. We're guaranteeing that anything that is iControllable will have an input map and a handles input method. So if something's controllable, obviously it will have an input map in order to determine how you control it. And to handle input, that will be determined when we press the up arrow key, what happens. How is that handled? Alright, so that is it for this video. Next video, we will work on the controllable game entity class. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to take a look at the controllable game entity class. So let's go to our Solution Explorer. So right click the game object folder and go to Add Class. We're going to call this controllable game entity. So controllable game entity. It's going to be a public abstract class. So when you can control an entity, that means it can be moved. So it's going to be a derivative of movable entity. Alright, what we did last video is we created an iControllable interface. So we're going to use our iControllable. Okay. So let's add our property here, which is going to be public input map, and that's from iControllable. Get private set. So that is from iControllable. Let's add a private field. So at the top of the class, let's add private read only input system underscore input system. Alright, between the private field and the public property, let's add the constructor. This is an abstract class, so we can make this a protected constructor. Controllable game entity. The parameters are input system. We need a way to have a reference to the input system. The color for our entity. Remember, this is a derivative of movable entity, which is a derivative of game entity, so we need to have color. So we need to add using Microsoft.xna.framework and using PGL2D.input. So color vector 2 position, float angle, float speed, string texture name, and then we're going to call base. And then we're going to provide the color, position, angle, speed, texture name. All right, what we want to do here is we need to create the reference to our input system. So underscore input system is equal to input system. Okay. A controllable game entity. This is a derivative of movable entity. So we have a update entity method that we could override. Now I'm going to seal this. I'm going to seal this and I'm going to provide the pre and post pattern to our method. So let's override the update entity and let's seal that. Protected. Override update entity and let's seal that. Sealed. So protected, sealed, override, void, update entity. And we call base.update entity. The pre and post pattern means that it's using the template pattern. Before we do an action, we might possibly want to do something before that. So that is the pre portion of that. Then we do our action, and then we call a post, and then we perform whatever we want to do after the action. In this case, we are moving our object. So before movement, we might want to do something to our object, process our movement, then after our movement, we want to do something else, possibly. So pre-movement, game time. Process input, game time. Post movement, game time. So those haven't been created, so let's go ahead and create those. Private, void, process input, game time, game time. So this is going to call that handle input that's from iControllable, but we need to prepare for that. Input map dot update. We need to update our input map by using the input system. That's why we needed a reference to our input system. For our inputs, if you remember last video when we created iControllable, the first parameter is a list of available keybinds, not all keybinds, available keybinds. So we need to get that. And we get that by using the input map dot keybinds dot where. We're going to use link and we're going to use where. Predicate k dot inputs dot count. And we're going to have another predicate here. So we're going to count the inputs based on a certain mode. And where, if that is greater than 0, that we are going to use that k. We're going to use that input map keybind. So we're going to count based on this predicate I. I.mode does not equal to released, and I.mode does not equal to input mode.none. So what this is going to do is it's going to count all of our inputs that if they're pressed or held. If that is greater than 0, we will use that keybind. Remember, keybind has a name, an action, and a list of inputs. So if that keybind, let's say attack, if any one of those input modes are either pressed or held, in this case we're doing the opposite, we're checking to see if it's not released and it's not none, which means it's either pressed or held. If that is greater than 0, that keybind is actually available for us to use. Let me explain this a different way. we have a keybind and we call that attack. We can attack by having space or enter, or let's say the number 1 key. Input map, keybinds, where k.inputs.count. Let's say I'm holding down the space bar, which means enter and 1 is released or none. But that action is still valid because the count, that will be 1. We're only holding down one of the 3 buttons, so that will become 1. So the attack action is valid, so that is why we check to see the count, if the count is greater than 0. So this is more complex than what we've been working on, where we have one predicate and then another predicate internal to that. So we are getting the list of available keybinds based on the fact that if any of the inputs from that current keybind is either pressed or held, then that keybind is available for us to use. And we're going to call it .toList. Okay. Once that's done, we're going to call handle input. And we're going to provide inputs and game time. Alright, so let's go ahead and make that method public. Abstract void handle input list keybind available keybinds game time. So that is from iControllable, and we're making that abstract because a controllable game entity, it has to be handled appropriately, so we make that abstract. Now let's add our pre and post movement methods. These are going to be empty. Not everything will need to process information before or after we moved. So protected virtual void pre-movement game time. Base implementation will be doing nothing. Protected virtual void post movement game time. Base implementation will be do nothing. The last thing we want to do for this file is to actually set the input map to be a new object. Alright, so that is it for this class. Next video we'll take a look at base game. So I hope to see you next time. Hey, Nathan here, welcome back to another video for the PGL2D Alpha series. And we're getting very close to the end of the series. There's only one big class we have left to do, and that's going to kind of bring everything together. And that is called the base game class. So let's expand the Solution Explorer here. Right click the game folder and go to add class. We're going to call this base game. Now this is going to be a public abstract class. Now this is going to actually be a derivative of Microsoft.xna.framework.game. Okay, let's set up some of the properties here. So this is kind of going to bring everything together that we've coded so far. It's going to have a input system, a screen system, and it kind of bring everything together. So the first thing we want to do is create a sprite batch property. Public sprite batch Then we need to add using Microsoft.xnative framework.graphics. Sprite batch. Get private set. Next, we need to have a input system. A game will have one input system. Input system is just a way for us to use when we update our input map. Public input system. We need to add using PGL2D.input. Get and private set. Next, we need to have the screen system. Our game is just going to have one screen system, which could have dozens or hundreds of screens if we so want. Protected. Screen system dot screen system. Since the namespace name and the class name is the same, we need to call it like that. So screen system dot screen system, and we're going to call the property screen system. Get private set. Next, we need to have a property to get the viewport, and the viewport is retrieved from the graphics device. So public viewport, and this is going to be an expression body property. Graphics device.viewport. The next property is we are going to have a rectangle to hold the dimensions of our window. You know, is it 720p, 1080p? We're going to have dimensions for that. So public dimensions. And then we need to add using Microsoft.xnative framework.graphics. Dimensions. Get and private set. This next property, public vector2. Absolute center. That's going to be the absolute position for our center point. The width divided by 2 and height divided by 2. Where is the center point of our game window? The absolute center. Okay. Microsoft.xnative framework.game. That provides a load content override, or we can override load content. Now I'm going to seal that. Protected, sealed, override, void, load content. Because there's no need to load additional content. The screen system is going to load each individual screen's content itself. So load content, sprite batch, equal to new sprite batch, graphics device, screen system dot load screen content. There's no need for derived game classes to load content because the screen system is handling that. Update. That's another thing that game and Microsoft.xnative framework.game, that's another thing that we can override. I'm going to seal that as well. Public or protected. Sealed. Override. Void. Update. Game time. We're going to call input system.update and screen system.update. We're going to provide game time here. And base.update. Game time. Okay. So most of everything will be sealed because our screen system is going to take care of it, and then we will have update entity and update screen, or draw entity and draw screens instead of the update and draw method directly. Last thing we want to do is we want to add the draw class, which is another thing we need to override from game. So protected, sealed, override, void, draw. Game time. Graphics device dot clear. Sprite batch dot begin. Screen system dot draw. Game time sprite batch. And sprite batch dot end, and call base dot draw. Game time. Now, probably in the beta or full release of this library, I'm going to stop doing this, because there might be some cases where we want to draw in a separate sprite batch. For example, if we need to transform or do anything out of the ordinary other than just the standard begin. So I'm probably going to pull that out of this method and put that in the screen system, each individual screen system. And I might even go a step farther. But that's for a later release. As you see here, we have an error with clear. Now let's go to the very top here and let's create a private field. Private. Read only. Color underscore background color. Alright, let's scroll down to the very bottom, and where we have draw, graphics device clear, let's pass in underscore background color. Alright. One more field we want to add is protected. Graphics device manager graphics. Alright, the last thing we need to do for this class is to add the constructor. Protected base game opening parentheses. Now this is going to accept a width and height. Int width, int height. That way we can say if this is 1920 by 1080 or 1280 by 720 or whatever we want to have the window be. Int width and int height string content root directory and color background color. So let's create our graphics object. So graphics is equal to new graphics device manager this. Now before the semicolon, let's add opening and closing curly brackets. Let's set the preferred back buffer width is equal to width, comma, preferred back buffer height is equal to height. Alright, after the closing curly bracket and the semicolon, let's set up the dimensions. Dimensions is equal to new rectangle 0, 0, width, height. Alright, let's set the absolute center is equal to new vector 2 width divided by 2.0 f, height divided by 2.0 f. So that gets the absolute center position of our window. Content.root directory is equal to content root directory. Input system is equal to new input system. Screen system is equal to new screen system. Screen system.screen system. underscore background color is equal to background color. And that's it. Alright, so that is it for this video. I hope you enjoyed it. Let's do a brief overview. Alright, let's do a brief overview quick on this. So we have a private field that holds the background color for our game. It's read-only. It's only going to be set once. Next, we have a protected that's accessible in the derived classes that holds the graphics device manager object. We have a constructor that initializes the graphics object and sets the width and height of our game window. Our dimensions are set based on the width and height we provide. The absolute center points to the center width and the center height of our game window. We set the content root directory, and we create new objects for input system and screen system. And then we set the underscore background color to the desired background color we want. For properties, we have a sprite batch, input system, screen system, a viewport which just returns our graphics device.viewport, the dimensions of our window, and the absolute center position. Then we have 3 sealed methods. Loading content. We load the sprite batch, we create a new sprite batch, and then we call screensystem.loadScreenContent. Updating. We seal that. We update our input system and update our screen system. Draw. We seal that. We clear our graphics device by using the underscore background color. We call spritebatch.begin. We draw all screens, and then we call spritebatch.end. So that's it for this video. I hope you enjoyed it. The next few videos are going to be very short. We have our game screen and 2 extremely short videos to extend the Vector 2 and random. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. In this video, we are going to discuss the game screen class. So let's expand the Solution Explorer here. Let's go to our screen system. And let's right-click the screen system folder and go to Add Class. This is going to be Game Screen. Alright, let me make this smaller. This is going to be a public abstract class. Game Screen, and that's going to derive from base screen. So this is just going to, all this is going to be used for is holding a reference, which will set this as a public property, to our base game. Now we need to add using PGL2D.game game get and private set. Alright, let's create our constructor protected game screen. For the parameters, it's going to have base game, bool accepts input, bool is frozen, bool is hidden, and is frozen, that's going to default to false, and is hidden, that's going to default to false. Those are going to be optional parameters. Then we need to call base, and then we need to provide accepts input, is frozen, is hidden. Inside of our constructor, all we need to do is set game is equal to base game. Alright, there is one method I want to override in this class, and that is the load entity content. Protected. Override. Void. Load entity content. for each var physical entity in entities.of type physical entity. We need to add using PGL2D.game object here. So for every physical entity, we need to call physical entity.load content game.content. Alright, now we're going to do the same thing for text entity. For each var text entity in text entities text entity.load content game.content. Alright, since this is going to be standard practice for every screen, it's beneficial to have this in the abstract class. But we can't add that to base screen. It has to be game screen because game screen uses our base game reference, which we get game.content. That's where we get our content manager from. Alright, so that is it for this video. I hope you enjoyed it. The last two videos are going to be very short. So I hope to see you next time. Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video, we are going to create an extension method for the vector2 structure. So let's expand the Solution Explorer and let's go to the utility folder and add class. We're going to call this vector2ex, or whatever your naming convention is for extension methods. Alright, I'm going to make that small. It's going to be a public static class. Alright, so we're going to create one extension method for vector2, and that's going to be reflection. Now, vector2 has a method to do vector reflection, but I prefer my way of doing the vector reflection. It's a little more mathematics, but I just prefer that way of handling vector reflection. Public static vector2. We need to add using Microsoft.Exadata framework. So public static vector2 reflect this vector2 v comma vector2 n for normal. Return v plus vector2 dot multiply n comma 2 times vector2 dot negative v comma n. I did a video game mathematics video that discusses vector reflection. Go ahead and check that out on what this means. It's a pretty lengthy video. Let me pull it up actually. So I have a monogame advanced video that discusses vector reflection, and I also have a video game mathematics tutorial number 5 that discusses that. The video game mathematics is about 40 minutes, and the actual monogame advanced video is about 20 minutes. I will put links in the description for those. If you do not know what this does, check out the video game mathematics video. That will explain how to get the actual formula to get vector reflection. And I also explain my thoughts on why I prefer this over the actual vector2 reflection. Alright, so that is it for this video. Next video, we will add an extension method for the random class. So I hope to see you next time. Hey, Nathan here. Welcome back to the last tutorial for the PGL2D Alpha series. And in this video, we are going to create an extension method for the random class. So let's go to our Solution Explorer and let's go to the utility folder and add a new class. And I'm going to call this random EX. I'm going to make that smaller. So this is going to be a public static class random EX. And it's just going to have one method for right now. Public static int. So random, you can get a next or next double. Next is a integer value between a minimum and a maximum. I want to add a next odd, which is an integer value, just it gets the next odd value. This random int min int max. Int num. So this is just going to loop until we get a odd value. Do. Inside the do block, we'll set num is equal to random.next min comma max. Alright, inside the while parentheses, while num parentheses 2 is equal to 0. So while the number is even, we'll just repeat the process until it's odd. Return num. So the first thing we do, we use a do while because we need to set number to some value before we can check. So do num is equal to random.next min max. While the number is even, we repeat the process. If it is odd, we return num. Let's also, at the top, let's also add a check for if min is equal to max, throw new argument exception. We'll throw a new argument exception. Let's say max cannot equal min. And for the parameter name, let's set the parameter name to be max. Actually, we'll use the new name of action for max. Okay. So those two cannot be equal. If it is, it's going to throw an exception, because if it is equal, it's just going to be a infinite loop. Because if you provide an even 2, if you do, let's say, random.next odd 2, 2. Random.next 2, 2. That's just going to return 2. So this will be an infinite loop. So max cannot equal min. Okay. So that's just a check that we need to implement for that. So that's it for this video and this series. I hope you enjoyed it. So stay tuned for the next video, which will just do a looking back on the series. So I hope to see you next time.